Hello dear students, very good afternoon. Myself I am Vijaya Kumar. Vijaya Kumar. We shall be discussing about computer organization through GTQ. Okay, fine. So that is gate through questions. Fine. So as you know that the gate exam will be definitely questioning your basic fundamentals. Okay, what is your foundation in that particular subject? Okay, so we have to concentrate in that perspective. Okay, fine. So there are different topics. So based on that we'll go one by one. So this is computer organization subject we shall be discussing in a very simple way and elaborate questions also, right? Fine. So be ready all of you. So as you know that this subject has been introduced for electronics and communication for GATE from 2021. So before that there was a subject called as microprocessor. So in the place of that subject, so this computer organization subject has been started. Okay, so as you know, like in initial years they may give some few questions, like one question or so, but now as the days go on or years go on, definitely the number of questions can increase. Is it clear? The same subject has got very good priority in ESC syllabus, but in especially for the GATE exam you are having these are the topics like machine instructions, addressing modes, ALU data path, control unit and instruction pipeline. So as you know, even the syllabus looks like 3 lines, you require a lot of basic fundamental concepts to answer the questions. So the GATE questions look very simple, but you need to have a thorough understanding of the basic concepts. Is it clear? So you may have like at least one question or two questions. Sometimes the questions can be linked up with the other subjects like digital electronics also. Is it clear? So I shall be discussing about the questions in basic level and also in the advanced level for certain topics whichever are possible. Is it clear? Right. So here this is the syllabus, as you know, like the basic syllabus which is present. So if you go in detail, like these are the different topics from which you can expect the questions. So let us have a little bit of glance on the total topics which are possible to have certain questions. Is it clear? So you may have questions on like basic operations of CPU, like fetch, read, write. It can be memory or IO read, IO write. Similarly, it can also be based on the bus structure of the CPUs. Okay, it can be the bus structures of the CPU. Okay, and it can also be, wait 1 minute. So it can also be based on the okay, it can also be based on the important registers which are a part of architecture in the CPU. Is it clear? So there can be different possible questions in these topics, right? So you can have questions on important registers of CPU. We shall discuss what are the basic level of questions in that. Similarly, what are the next level of questions which can be possible at higher level also. Okay, fine. And you may also have the performance of a CPU, by which you find out the execution time, in which you find out the execution time. Based on the execution time, you can find out how much fast the instructions can be executed in the CPU. Is it clear? Or for a particular CPU. Fine. So now we shall discuss these are the basic topics, some of the topics, and other topics like if you go to the next topics, like you can have instruction format, and other one is the instruction set architectures. The three types are there: stack based, accumulator based, and the general purpose register based, which again consists of register memory and register architectures, right? And the important topics like you also have are this one, that is addressing modes and instruction encoding. I think this year also the question was given on instruction, last year, previous year, that is in 2024 you got a question on instruction encoding. And different instructions, especially you may not get directly instructions, you may get a simple instruction, they may ask you the addressing mode, or they may ask you some set of instructions and what is output of some program. These are also possible, right? Similarly, that is the first part. Second one is the ALU, and the same thing I already told you, performance of CPU is just finding out the execution time when some clock frequency is given, number of clocks are given, and some set of instructions are given. Apart from that, when there is a huge program, there are different type of instructions like data transfer, or it can be arithmetic and logical, it can be branch instructions. When couple of instructions are there, when more number of instructions are, different groups of instructions are there, then how do you find out the performance of that particular CPU? That is one type of question. Other one is like we'll be solving some questions on the ALU data path and also control unit. So in the ALU, how this data path is there, how to understand the control unit questions, okay, two types like microprogrammed and hardwired. Similarly, what is the role of improving some portion of the processor so that you can get the overall speed up to be improved. That is what is given by Amdahl's law. And finally, the questions can be discussed on the instruction pipelining, where the overlapped execution of instruction will take place. So ये पूरा कैसे होता है, we shall be discussing certain questions, right? Okay, fine. So no need to worry, I'll be discussing some basic questions, then we'll go to the next level questions, right? And finally we can also discuss some register windows, like in some RISC type of CPUs you have huge number of registers, like there will be some registers which can be grouped into several types like local or common registers, by which the parameter passing time can be reduced by using some registers, okay, overlapped register windows. So we shall discuss also certain question on that. So these are the different topics on which we are going to solve the questions in computer organization, which is exclusive for the electronics. Is it clear? So this subject is also there in computers department, but here the level of questions are different, okay. So let us not worry about the level of questions. So we shall study the questions. So the computer organization is especially meant for like understanding what is the memory system that is connected to the CPU and what is the internal architecture of the CPU, and also so let the questions on IO device may not be understood here or may not be required here. Main thing is to understand what is the memory system, what is the interconnection between the CPU, and also the design of the CPU. That is a core concept on which the questions can be expected. Is it clear? Right. So let us see how actually this can be understood through several type of questions. So let me start with basic types here, okay, fine. So the basic operations of CPU, as you know, it can be opcode fetch, it can be memory read, it can be memory write, it can be similarly IO read, it can also be IO write. So the same operations are simply given as how many memory accesses are done for a particular instruction. So the basics are always important to understand the questions. So GATE is one such an exam where you must be thorough with the foundation or basic concepts, then only you will be able to answer the next level questions. Sometimes the orientation of question is different. So this is how we are going to solve the questions, right? And we will be able to solve some questions on the cache memory also, like there are different memories, as you know, primary, secondary. In that most of the questions will be based on this particular cache memory, so which is used for frequently for storing the frequently used instructions and data, okay. So if one level of cache is there, how to solve the question, two levels of cache are there, how to solve the question, these all questions can be understood, right? And the sometimes like theory questions you may have a comparison of memories also, like which memory is faster, okay, fastest memory is register memory and the slowest one is the secondary memory. So speed and cost, this speed and cost is high here, high speed and high cost also as you come to this triangle, and capacity is very less and more in the secondary memory. Sometimes you may have a question to compare the different types of memories also. Is it clear? So these are the different topics we are going to study. Finally we will study what is the difference between, or we will solve some question, what is the difference between IO mapped IO and memory mapped IO. And I just gave a slide just to understand the definition so that you can follow easily. Is it clear? So that you can understand like just a basic recap of the concepts, okay. So you may have questions on memory access time, you can have question on memory word, it can be memory with word addressable or byte addressable. Similarly you can have a cycle time, memory cycle time. And you also know that there are two types of computers which may be addressing the memory in word format, or it can address the memory in the byte format. So these are the important types. In the byte format there are two types again, little endian and big endian. So we shall be covering all these topics, the different type of questions, okay, fine. So hope my outline is fine for today's GTQ, right? Is it clear? Fine. So let us discuss this particular questions based on the topics, okay, fine. Okay, so first we shall discuss because I have taken different questions here, okay. You should also know like the questions can be random sometimes. I'll go with the basic type also, but the questions can be random sometimes. Okay, let me just go with the basic type first, then I'll come to the next level topics. Okay, so basic type is, I would mean like memory related, and other one is the internal architecture. Okay, so the computer organization is especially the implementation part of the CPU, means how this particular memory is there. So what is the memory system that is present, and what is the memory interconnection, and other one is the interconnection, and other one is the CPU design. So we will be concentrating questions on these topics, right? Memory interconnection, other one is the CPU design. So first let us take a very simple question, and then we will go to the next level of questions. So I think my flow is fine, audio is fine, everything is fine, clear? Dear students, everything is fine, no? Right. So we will continue that. So you be ready with the pen and paper, and always remember that the exam which you are going to respond, the time which is given to you. Okay, so time is 3 minutes of time approximately, let us say. So based on that only you have to practice the questions. Okay, whether you are practicing at home or wherever it is, you have to think in that perspective, right? Okay, fine. So let us discuss the questions based on this particular topic, right? Fine. Okay, let us take a very simple question. A CPU has 24 address lines, then what could be maximum memory that can be interfaced to it. Okay, this is the simple question I am just taking. So option A 16 KB, option B 16 GB, option C 24 MB, and option D 16 MB. Okay, just find out what is the value. I am just giving you few seconds. Yes, Samir, you can expect questions in the gate, definitely, the subject is there, no? Yeah, very good, thank you for your responses, very good, yeah, people are alert. Yeah, so every year the number of questions may change. Okay, it's gate is completely like we cannot expect a particular number, but questions are possible. Yeah, Suman, correct, your answer is correct. So somebody has written the answer is D. Okay, correct, very simple. So if n is the total number of address lines, then maximum memory that can be connected to that particular CPU is how much? 2 power 24. So what is the value? 2 power 4 into 2 power 20, that is 2 power 4 is 16, 2 power 20 is 1 megabyte, and hence the maximum memory that can be connected with that particular CPU. So if you take a CPU, the memory, normal CPU, definitely the basic CPU we consider memory to be connected externally. So what is the maximum possibility? 16 megabytes, because n is 24, 2 power 4 is 16, 2 power 20 is 1 megabyte, therefore total memory that this particular CPU can address is how much? 16 megabytes. So it's a very basic type of question, right? So hope you have understood. Yeah, all of you, is it clear? Yeah, some people have responded. Yeah, correct. So whoever has opted for D, that is correct. Yeah, correct, D is the correct answer. Hope everyone has understood. I think no doubt, simple question. Right, okay, fine. So is it clear? Right, very simple question. Okay, so I'm just tracking from basic. Okay, how to use these lines for other purpose also we shall see carefully. Right, next one is like if the memory is present for a particular CPU, because in the CO you should know especially about memory concept. If you don't know memory concept, you cannot understand the next questions. Okay, fine. So that's why I'm going from a very basic level of questions. Okay, don't worry, we'll cover different type of questions. Next one is like for example, say next one is like for example, if you want to know how this memory is present, like I told you already, we discussed about two types, that is word based, and other one is word addressable and byte addressable. Okay, let us look at the next question. Word addressable of, for example, say it is 16 bits wide. Okay, so if 10 instructions are stored from 400, what is the address of last instruction? So slowly we'll go to the next level questions. Okay, instruction. Okay. So the address is here in 10. Okay, there is decimal form. I am giving the answers also in decimal form only. Yeah. What is the answer? These are all very basic questions. Can you just tell me the answer? Yes, what is the answer? Very simple. A CPU can address memory which is word addressable of 16 bits wide, means the memory word length is 16 bits. If 10 instructions are stored from some 400 address, what is the address of the last instruction? Yeah, so very simple. Now observe carefully. Whenever you get a question on any memory, just first understand, okay, first understand how the notation is there. Okay, fine. So this is the memory, right? So here is the memory. In this memory there are some 10 instructions stored. Okay, so here each instruction length he has not given, so instruction by default you assume it has only one word. So here the memory word length, this one is 16 bits, that is what he says. So this one is 16 bits. So memory word length is 16 bits. So if 10 instructions are stored, means here instruction 1, instruction 2, so on etc., some instruction 10, right? So here the point to note is that assume nothing is given for us, so assume the instruction length is only one word, so where it is starting from 400, so it's a decimal type address, right? So I'm just writing directly, so 401, it is a word addressable memory, it's not a byte addressable. So here the memory is which one? Word addressable. So word addressable means irrespective of how many bits are there for one register or one memory location, the total memory location will have only one address. So therefore we are considering this entire instruction, whether the word length is 16 bits, 8 bits, 32 bits, whatever it is, we are taking the entire location as only one address. So therefore 400 so on etc. So what is the last address in decimal form? 409. He is asking what is the address of the last instruction. So very simple. So it is starting from 400. So the last instruction will be at 409. So the answer will be option C. Option C. I hope you are able to follow the questions, right? So these are very basic questions only. We are starting with simple questions only, right? Done? Okay, right. Hope you are able to follow this. Now, so we shall solve some questions on important registers. So now we shall come to the architecture part. So most of the questions, once you know the concept of memory, then you can understand the concept of the internal architecture, the questions on the internal architecture. So in internal architecture, most of the questions will be based on the important registers. Okay, so there are two types of registers, as you know, that is general purpose registers and special purpose registers. So depending on the CPU, the special general purpose registers may vary, but special purpose registers are very common, like you have got memory address register, memory data register, and similarly instruction register, you have got the program counter, you have got like stack pointer, and also you have got the flag register. Sometimes it is also called as status register. Okay, so these are the different important registers which are possible in the CPUs. So based on the processor, general purpose registers can vary, like if you take a basic processor of 8085, you have got BCDHL, if it is 8086, you have got AX, BX, CX, DX, so on etc. In some process you may have R0 to some Rn-1. So the general purpose registers can change, okay, but these are the basic special purpose registers which are possible. So most probably here the questions can be posed from these special purpose registers. So memory address register, memory data register, instruction register, program counter, stack pointer, and flag register. Sometimes this flag register, as you know, is also called as what? The status register. Okay, so sometimes they may also give what is the status register value. Sometimes they may ask about the questions like this. So now we shall discuss about these registers also. Is it clear? So as you know that the processor has got different type of buses, address bus, data bus, and control bus. Based on that you can address the memory, and similarly within the CPU also there is some internal bus. So through that internal bus the registers will be connected. Clear? So now let us take some questions based on the special purpose registers especially. Okay, fine. So let us take one simple question. How to a hypothetical CPU has 32 address lines and 24 data lines. 24 data lines. 24 data lines. The length of MAR and MDR registers. So what is the length of MAR and MDR registers? 24 bits and 32 bits. 8 bits and say 16 bits, C is 32 bits and 24 bits and none. These are the options. So let us solve simple question. Okay, good. Yeah, Suman, Acha, Sheikh Mahmuda, fine, good. So Suman has answered. So what is the answer? Yeah, very simple. What is the answer? First of all, you should know what is the question asked. So here he is asking about MAR and MDR registers. So here first of all you should know what is MAR. MAR stands for memory address register. Memory address register. Okay, what does it contain? Memory address register is used to hold the address of memory or IO before it is placed on the address bus. So how many address lines are there? Definitely the register should be of that many bits to hold the address, right? So MAR will be equivalent to the length of address lines. Similarly, memory data register, MDR, stands for, so what does MAR contain? MAR contain, it has address of memory or IO. So it is used to hold the address of memory or IO before it is placed on the address bus. Similarly, MDR, or sometimes the question can also be like MBR, it stands for memory data or memory buffer register. Buffer register. Okay. So what it is, what is the purpose of its use? So here it is used to hold data before it is transferred to memory, or from memory. Means whatever is the data, see, don't get confused here. Data means data can, for anything from memory, it can be instruction, it can be an operand, whatever it is. So anything from memory, it will be first brought into MDR, then only transferred to some other registers inside the CPU. Similarly, any address or any data from processor to memory or IO device also, first it is held in the MDR. So that is the main purpose of MAR MDR. So now very simple, the question is like address lines are 32, so its job is to hold the address, so definitely it should be also 32 bits. Similarly, data lines are how many? 24. Therefore, this register should be capable of holding the data. So definitely it should also be 24 bits. Therefore, we can simply say that here this particular register should be 32 bits to hold the address, and similarly MDR should be 24 bits to hold the data. 24 bits. That's all. So very easy, direct question. Okay. So the answer will be how much? 32 and 24. Option C is the correct answer. Okay, right, these are some basic level. Next we will see the next type of questions, how the same questions can be given in a different way. Yeah, so option C is correct. Good. So slowly we will go to the next level questions. Okay, so these are basic questions I am trying to make you to follow, so that we can go to the next level questions. Okay, fine. So same questions we will try to understand in different way when we go for other topics, right? So everyone understood? Right. So you should know the logic of the processor clearly. So here this is the processor, right? This is the processor and this one is the memory. So from memory you can bring either instruction or data. So this is the memory. I am writing memory as M/M. This is the CPU or the microprocessor. Okay. So here memory is connected to the processor like this. Fine. Understood. So it can be some instruction code or it can be some data also, anything. So anything from memory, it will be first brought into which register? MDR only. So first either instruction, anything, it will be first brought into MDR, then only it can be transferred to some other register inside. Similarly, data also first it is brought into MDR, then only it can be transferred to some another register. Similarly, for example, I want to transfer any data from processor to memory also, then also the story is same. So first of all, the data is copied to MDR, then only the data can be transferred to certain location in the memory. So then only it can be transferred. So when you are accessing from memory, we call it as read, send to memory is the write operation, as you know it. Fine. In general, इसी को बोलते हैं हम मेमोरी एक्सेस बोलते हैं. सो मेमोरी एक्सेस में आपको वो इंस्ट्रक्शन भी ला सकते हैं, डेटा को भी ला सकते हैं और डेटा को भी भेज सकते हैं. इज इट क्लियर? सो कुछ भी हो सकता है, रीड राइट ऑपरेशंस एनीथिंग हो सकते हैं. सो उसको जनरली मेमोरी एक्सेस बोलते हैं ए वाला सब्जेक्ट में. अगर उसी माइक्रो प्रोसेसर सब्जेक्ट में इसको रीड राइट ऑपरेशंस बोल सकते हैं, मेमोरी रीड या मेमोरी राइट. यहां पर आपको जनरलाइज पूछेगा, हाउ मेनी मेमोरी एक्सेसेस करके पूछेगा. विल सॉल्व सम क्वेश्चंस, बाद में देखते हैं, एक एक देखते हैं वन बाय वन. ओके ना? राइट. आई होप यू आर एबल टू फॉलो एवरीवन. क्लियर? राइट. यस, गुड. Yeah, so yeah, I hope you are able to understand everyone. Clear? So we are going with the basic questions only, right? Fine. So that is about the different registers which we have got. That is the basic MAR and MDR. So these two registers, for example, if you understand carefully, ये वाला MAR MDR को प्रोसेसर के अंदर ही ये प्रोसेसर यूज करेगा ऑटोमेटिकली. वी कैन नॉट एक्सेस देम. फॉर एग्जांपल, जो कोई भी एड्रेस हो, प्रोसेसर से बाहर जाना है एड्रेस, वो एड्रेस फर्स्ट इसमें कॉपी होगा, देन ओनली बाहर प्लेस करेगा. सिमिलरली डेटा ऑल्सो एनीथिंग. सो MAR इज ओनली वन डायरेक्शनल. यू कैन नॉट गेट मेमोरी एड्रेस into this one, reverse नहीं होगा. MDR में you can send data or bring the data, but MAR you can only send the address from processor to the memory or whatever. It is only one way. Are you able to follow? Yeah. So like this, you'll have some questions on MAR and MDR. Now let us go for the next special purpose register, how the questions can be possible. Okay, fine. Next one. Next question. The PC program counter register for a CPU has address of next instruction to be executed. Okay, data of current instruction, similarly address of current instruction none. So what can be the value? What is the option? Very simple question. We'll इसी register का अलग अलग types we'll discuss. Okay, basic type and next level कैसे आएगा, different types पढ़ेंगे इसी question PC के बारे में. We'll study in different way. Okay, so these are very simple questions. Tell me what is the answer. Very easy. Yeah, very good. Yeah, some people are responding. Good. So it should be an interactive session. You can respond your answers. That will be good, so that it will feel interesting, right? Both of us, because in online you must. It's a YouTube live, right? So it will be interesting if you respond. And don't worry and don't wait for other answers. बाकी के लिए मत सोचो. पहले आप लिखो. आपका आंसर क्या हो सकता है, so that when it is correct, you'll feel happy. Your confidence level आपको बढ़ेगा. If it is wrong, then you can learn. So don't wait for other answers. आपके friends के answers के लिए wait मत करो. पहले आप अपने आप बताओ. हाँ बताइए. Program counter contains what? Address of the next instruction to be executed. So the same program counter question we will discuss in different way. As a purpose, ये है simply purpose of register. इसी program counter का, see program counter will contain what? Address of the next instruction. So when some program is executing, who is the register? Which is the register responsible for making the order or taking the order of execution of instructions? Program counter. For example, normally we celebrate some functions or some birthday parties, whatever it is. उसमें एक organizer होता है, like anchor होता है. That anchor job is what? To announce what is the next program. So in the anchor's mind always रहेगा क्या अगला program है. What is the next program जो चलना चाहिए. Audience enjoy करते रहेंगे. So in the same way, in microprocessor, the program counter register is one special purpose register which contains the address of the next instruction to be executed. Don't get confused here. Here instruction can be of one word, instruction can be of 2 words, instruction can be of 3 words also. So instruction एक word से ज़्यादा है तो then the program counter will automatically get incremented to the next word whichever is there. It can be instruction, it can be part of instruction also. That is what you should understand very clearly. Okay, it means what I mean to say, understand carefully. See, the level of questions can be different. If you know the basics, you can answer any type of question. आपको basic नहीं मालूम है, simply mug up कर लिया है, program counter contains address of next instruction. Question जब twist करेगा आप लिख नहीं पाओगे. So therefore यहाँ पर definition में it contains address of next instruction only, but how the questions can be given, observe carefully. For example, एक instruction है memory में, this is the instruction, okay, understand carefully. So for example, instruction 1 is there, instruction 2 is there, right? Fine. So दोनों instruction are of only one word. One word means it is occupying one memory location, this is also occupying one location. Let us say it is present at 300, it is present at 301. To make it simple मैं इसको decimal numbers में address ले रहा हूँ, don't get confused, okay? So instruction 1 इसका fetch हो गया. For any instruction what is the first operation? Opcode fetch. Opcode अंदर आने के बाद decode होने के बाद भी processor समझेगा. That is the main thing. So here this is the processor, right? This is the microprocessor CPU. So ये memory connected इसके साथ, okay? Memory is connected, let us say like this, okay? So ये instruction fetch होके अंदर आकर decode होने के बाद ही processor will understand what is there in the next location. बिना decoding it cannot know what is there in the next location. Are you getting the point? So therefore here unless until one instruction is decoded, processor cannot interpret whether this instruction is only one word, ये एक word का instruction है या 2 word. मतलब कई बार instruction 2 memory locations में present हो सकता है, कई बार instruction 3 locations में present हो सकता है, depending on the type it can address. Are you able to follow? So question अलग अलग तरीके से हो सकता है. In general यहाँ पर दिया हुआ है, in general मतलब इसका opcode, for example ये program counter, ठीक है, अच्छी तरह समझिए, ये program काउंटर है. सो प्रोग्राम काउंटर में इसको फर्स्ट फेच करना है तो प्रोग्राम काउंटर विल हैव 300, राइट? सो ऑपकोड फेच हो गया, इमीडिएटली प्रोग्राम काउंटर गेट्स इंक्रीमेंटेड बाय 301 बिकॉज नेक्स्ट इंस्ट्रक्शन इज प्रेजेंट एट नेक्स्ट एड्रेस. दैट इज द मीनिंग ऑफ बेसिक डेफिनेशन. बट फॉर एग्जांपल लेट अस से इंस्ट्रक्शन एक वर्ड नहीं है, इंस्ट्रक्शन इज more than one word. For example, assume that instruction 2 is 2 words. This one is a one word instruction, it's a one word, right? Now let us say this instruction is a 2-word instruction. Now observe carefully. So in this case, observe carefully, 301, 302, okay? Don't get confused, okay? Now first instruction is completed, let us assume. Second instruction, again the instruction code will be first fetched. The opcode means instruction has 2 parts, opcode and operands. So therefore the instruction तो fetch तो हो जाएगा, अंदर fetch हो गया, immediately PC में कितना होगा अभी? 302 होगा. 303 में let us assume that instruction 3 is there. So यहाँ पर 303 में नहीं भागेगा. So first opcode को लेके आया है, यहाँ पर अंदर आने के बाद after decoding then it understands that this particular instruction is a 2-word instruction. So program counter is responsible to bring the next part of instruction into the microprocessor. Are you able to understand the basic question and the next level question? Basic question में है what does PC contain? Address of next instruction, वो common है. But whenever 2-word instruction हो सकता है depending on the CPU. Let us say memory word 8 bits ही समझो, memory word 8 bits ही है ना? Memory word is only 8 bits. So one word is 8 bits here. This location is 8 bits, right? Fine. So a 2 byte का instruction, 2 byte instruction है. So first byte whenever it is accessed, after accessing, then the program counter is responsible to bring the next value also. So whenever opcode is fetched, we call it as fetch, but the second part opcode नहीं है, some operand है. Whenever you are accessing this one, then we call it as simply memory read. Memory read operation or in general memory access करके बोल सकते हैं. Are you able to understand the difference? अब बताओ, is the statement true now? No. So here program counter contains address of next instruction बोला है, but here program counter is having what? 302. 302 is a part address of the next part of the instruction. Are you getting the point? It is not next instruction, I2 का ही second part है. That is what you should understand. So instruction has got two parts, opcode and operands. So to bring the operands, it may have more than one operation also. That is what you should understand. So basic level of question अलग है, next in depth of question is different. So like this you should know how the question is posed. Got it? Right. Clear all of you? Done? Okay, good. Right. Okay, fine. Shall we go to the next question? Right. So we'll come to that next questions, like how the program counter question is asked in the instructions, how it is there. Let us see one by one. Okay, fine. Okay, fine. Next question. Like for example, say I am giving the next special purpose register. If an instruction push R2 is executed, if an instruction push R2 is executed where R2 is equals to 4975H, means hexadecimal value is given, and current value of SP stands for stack pointer, current value of stack pointer is equals to F008 word length of memory is equals to 16 bits. 16 bits. See, question can be randomly given anyway, okay? 16 bits, and CPU is byte addressable. CPU is byte addressable. Okay, fine. The value of SP after execution of the instruction is, value of SP after the execution of instruction is. Okay, you must tell what is the value. F00A, F006, F010, this is the value. So tell me what is the answer. You can have different type of questions as such. Yes, what is the answer? So you have to concentrate more questions on stack memory, stack pointer. Okay, there are different type of questions. I have given you some basic question now. We shall solve some more questions in the next part also. Yeah, someone has answered. Good. Yeah, see, I want everyone to solve and respond. Okay, if you solve and respond, it will be practice for you. It will be good enough to have a mutual coordination. You should solve it and answer. Don't worry whether it is wrong or right. You just try to solve and respond. Good. Yeah, some people have responded. Good. Okay, don't worry for the answer whether it is correct or wrong. First you try to respond, and the questions data will be randomly given, है ना? So data random होता है. हाँ देखो, हाँ क्या है, क्या पूछा देखो, very simple. हाँ, so understand carefully what he has given. Okay, right. हाँ देखिए, so understand the question carefully. देखो यहाँ पर आपको मालूम होना चाहिए stack का मतलब क्या है, stack pointer का मतलब क्या है, ठीक है? So what is stack? Stack is a part of memory to store the temporary data and also the value of program counter for some instructions. So stack में जब data जाता है, the instructions which are used are push and pop. Push instruction is for storing the data into stack. Pop instruction is for accessing the data from the stack. But the processor may be of word addressable memory or byte addressable memory. Is it clear? So उसके ऊपर depend होता है वो कितना बार decrement होगा या increment होगा. So let us understand it carefully. Very simple. So observe carefully. This is the stack memory, right? So very simple. So whatever is given, you just write down whatever is the given information. So here push R2 is the instruction. R2 contains some data. 4975 is the data. So R2 register contains some data called as 4975 in the hexadecimal form, right? Fine. So this is the stack memory. What is the word length given to you? How much it is? What's a word length? 16 bit. Word length is a 16 bit. Means 2 bytes are present in one memory cell or one memory location. Okay. So one memory location will have 8 bits. 16 bits means how many bytes? 2 bytes. 2 bytes. 2 bytes. So 2 bytes are there in one location. Understood? So therefore here stack is a part of memory, means RAM only, to store the temporary data. Lekin always understand stack pointer is a register which always contains the address of the latest temporary data which is stored in the stack memory. What is the technique of stack? Last in first out. How? We'll see that. Right. So now here whenever a stack pointer question is given, what is the value of stack pointer given to you? F008. This is the data value of stack pointer, right? Fine. So stack pointer is a register inside the CPU only. We are just denoting like that, है ना? So stack pointer में कौन सा address है? उस address पर already some previous temporary data present है. Some temporary data है. वो temporary data क्या है? कुछ भी रहने दो. Let us not worry. So अभी क्या बोल रहा है? So it is a byte addressable memory. Byte addressable मतलब step size कितना होगा? What is step size? Means how many bytes are there in each memory location? That is step size, right? Means the difference between two memory addresses. अब बताओ यहाँ पर push instruction का मतलब है to store the data into stack. Pop means to bring the data from the stack. So push instruction purpose is to store data into stack. To store data into stack. To store data into stack. Pop instruction purpose is to access data from the stack. To access data from stack memory or stack memory, both are same. ये basic purpose है two instructions का, push and pop. So now what he says, so here some register is given to you, R2, इसका content ये वाला है, and he says that if it is stored into stack, what is the value of SP after execution? So now the point to note here is byte addressable memory. Byte addressable means every byte of memory will have some address. So here F008 is given, some address is given, right? It means this memory location 2 bytes are there, so the address is some F00. So what is the step size now? I want to go for the next one. Like, what is the next address? Push means storing into stack. Always remember, stack pointer में जो address दिया है, it indicates the address of some temporary data which is already existing in the stack memory. So where it is stored now? -2. What is the step size? Step size is 2. Step size is 2. What is the meaning of 2? 2 bytes per one location. Are you able to understand how many bytes are there for one? That is step size. Okay, we call it as step size. So the previous address will be how much? F006. Okay, right. Fine. So randomly there I am just taking like that. So -2. So step size means what is this value now? SP -2 will be the value here. So because step size is 2. And only one register दिया हुआ है 16 bit का register है, therefore ये वाला content, this content is able to, it can be accommodated in this location or not? Yes. So therefore, so push operation means whatever SP is there, it will be -2, then it is placed, because it is a byte addressable memory. अगर word होता तो F007 होता था, but it is a byte addressable means step size को decrement करना पड़ेगा. So F006 and this content is copied to the stack memory. So this is transferred to the stack memory. So normally which type of operation it is? Memory write operation. In general बोलने से memory access करके बोल सकते हैं. Fine. So this 4975 will be stored here. Now what is the question he is asking? The value of SP after the execution of instruction. So tell me, what is the value of SP? How much? F006. This is the value of SP. Agar sometimes question will be asked, what is the data at top of stack? So what is the top of stack data? Sometimes the question can be like this also. Top of stack data. What is the top of stack data? He may ask. What is the top of stack data? 4975. So top of stack data will be 4975. Means the current data, whatever is the current data presented, the current value of SP, उसी को बोलते हैं data at top of stack. So this data is called as simply data at top of stack. Okay, so don't get confused. SP is a register, it contains the address of latest temporary data. Top of stack means at the current SP value address, what is that corresponding data? Both are different. Okay, so these are the important points you need to understand for the stack memory or stack operations. Is it clear? Right. So answer is which one? Option B is the answer. Yeah, correct. Yeah, most of you have answered correct only. Great, fine. Now let us go for the next one. So the first year question was just based on these instructions only. Let me give you one more question. Is it finished? Right. Okay. I hope you are able to follow this. Understood everyone? This is top of stack data. Top of stack data means whatever is the data corresponding to the value of stack pointer address. That data is called a top of stack data. If you store some more data, again it will be -2 like this. Depending on the question it can change. Got it? Everyone clear? Right. Next one. Yeah, let us go for the next question. So we have to practice many questions based on the stack memory. Okay, fine. A CPU executes few instructions as given below. HLT means halt. Execute memory is word addressable. So there are different type of questions on stack pointer. Okay, so HLT means halt instruction. Okay, this is halt instruction. So what is the answer? So what is the answer? Yeah, some people have responded good. Have you solved, all of you? Done? Okay, right. So very simple question, right? Okay, now observe carefully. Here, if you let me just put here so that you can understand easily, right? So just now I told you what is a stack, how the stack pointer varies, these all points just now I have discussed. Very simple. So here push instruction is to store into stack, pop is to access from the stack. Very simple, right? So he has not given what is the word length, nothing, but he told that memory is word addressable, right? Fine. So whenever a question is given on stack memory, what I told you, immediately put the logic of stack. Okay, then you understand in a easier way. So here this is the stack memory, it is word addressable. Okay, right, fine. So very easy, this is the memory given to us. We don't know what is the memory word length, let it be, nothing is given. Okay, so take it as word addressable only. Okay, one address. So what is the current value of SP given to you? The current value of SP is 9003. Sorry, 9003. So as it is word addressable, this address will be definitely what? 9002. This address how much? 9001. This address will be 9000. Accepted? In hexadecimal. So this is some previous data. So WW is some previous temporary data. So stack pointer always contains an address which is the previous temporary data value. Okay, previous temporary data in the stack memory. Okay, some value I just took. Okay, that is the question. So very easy. Push is of 2 times, pop is of 2 times. In push operation, SP will be -1 because it is word addressable. Pop operation SP is +1 because you are accessing from memory. Is it understood? So very easy. So what is the answer now? So what is the answer now? Very simple. So first of all, push operation. What are the registers given here? R1, R2. So we don't know what is the value of R1. We don't know what is the value of R2 also. Some data is there. Okay, right. So some kind of data will be there here. So very simple. Now tell me what is the answer. So current value of SP is this one. Current value of SP is this. Okay, fine. So what is the answer now? First of all, push R1. Push R1 means whatever is the data, this data is transferred to this location. Means let us say this is some data 1, D1. This is some data 2, D2. Okay. So D1 is present here. Followed? Right. So what happens to SP now? SP -1. So because we are taking the word length as only one value. Okay, sorry, the word address means the address will be only one. Total memory location का एक ही address होगा, है ना? Right. अब बताओ, very easy. So 9003 -1 कितना हुआ? 9002. क्योंकि ये word addressable memory है, मतलब क्या है? Total memory location का एक ही address होता है ना? Byte addressable नहीं है. Is it clear? क्योंकि word length हमें नहीं दिया है. Are you able to understand? Again push R2. मैंने SP -2 हुआ है. यहाँ से लेने से -2 हुआ है. सो ये R2 का कंटेंट यहाँ चले गया. ये कौन सा डेटा है? सम डेटा 2, समथिंग डेटा 2. सो करंट वैल्यू ऑफ एसपी कितना है? यहाँ पर है. नेक्स्ट वन इज पॉप R1. पॉप R1 का मतलब है, ओके, आई एम जस्ट टेकिंग आउट दिस वैल्यू. ओके, डोंट गेट कंफ्यूज. सो इसको जस्ट आई एम जस्ट रिमूविंग दिस वैल्यूज. ओके, एज यू हैव ऑलरेडी नोन द ऑप्शंस. ओके, या, so don't get confused for that. So now SP का value है. अब बताओ, for with respect to the next instruction, the current value of SP should be considered from this location only. यहीं से लेना है, because this is the top of stack memory. समझ में आ रहा है आपको? Fine. अब बताओ, very easy. अब क्या करना है? Pop R1. Pop R1 का मतलब क्या है? So here this content, whatever is there, this content is accessed into R1, means data 2 R1 में आ गया. ऑटोमेटिकली SP क्या होगा? SP +1 इंक्रीमेंट हो जाएगा, बिकॉज स्टैक पॉइंटर ऑलवेज क्या next this temporary data का काम खत्म हो गया, finished, you have accessed from memory. What is the next temporary data? The next location. So SP is incremented by 1. Is it understood? Next one, pop R2. Pop R2 means what is that? This content is also again accessed into R2. It means data 1 is now present in R2. So in दोनों का purpose is finished, temporary data purpose is finished. So the next temporary data is present at this location. So SP will be automatically incremented. Are you getting the point? So therefore, what is the current value of SP? Very simple. How many times you have stored into stack, that many times you have accessed from the stack. So very easy. So SP value remains same. So option D is the correct answer. Whatever is the content of SP, it will remain same. Means SP will have 9003 only. Got it? So it's very easy. How many times push is there, that many times pop is there. So cancelled, -2 +2, done. So that is why. Sometimes question आपको पूछेगा what is the content of R1, what is the content of R2, ऐसे भी होने का chance है. So here simply exchanging the data. R1 content is R2 data, similarly R2 content is R1 data. Sometimes you may have questions as such also. Okay. So this type of question was given in first year like 2021 based on the stack operation. Got it? So you can have such type of questions. Yeah, option D, correct answer, good. Yeah, some people have responded it, correct. Yeah, I hope everyone has understood the answer. Is it clear? So in this case SP is -2, SP is -2, in this case SP is +2. So both get cancelled and simply it is simply SP unchanged value. Got it? Right. So like this you'll have the questions in the stack operations. Followed? Right, great, fine. Thank you for your responses. Everyone is involving, good. Yeah, I recommend, I appreciate if others also involve. Okay, fine. So that you'll have good rapport with the questions and all. Clear? Fine. So is it okay till now? Fine? Okay, fine. I think you are able to understand the questions based on the stack operation. So stack operations, you can have questions based on the word addressable or byte addressable, based on number of instructions, push pop, which are possible. Okay, so these are all different type of questions. Now let us go for the next special purpose register, one of the important register called as flag register. So let us discuss about flag register, or we can also say status register. Okay, so there are different flags which will provide you the status after certain arithmetic and logical operation. So there are 6 condition flags. Okay, by the status of these flags we can implement the program. Like for example, flags में 2 तरह के हो सकते हैं, कंट्रोल फ्लैग्स हो सकते हैं, कंडीशन फ्लैग्स हो सकते हैं. फॉर एग्जांपल सोचिए अगर आप फ्लैग रजिस्टर कंसिडर करने से यहाँ पर 2 टाइप्स है, कंडीशन फ्लैग से कंट्रोल फ्लैग. इसमें कुछ भी पूछ सकते हैं. मोस्ट प्रॉब्ली आपको एक कंडीशन फ्लैग्स के बारे में ज्यादा क्वेश्चंस हो सकते हैं. ओके, so condition flags, other one is control flags. Okay, fine. So a condition flags में 6 types possible है. Like you have got sign, zero flag, auxiliary carry flag, parity flag, carry flag and overflow flag. ये overflow flag को मैं simply OV से मैं denote कर सकता हूँ और मैं V से भी denote कर सकता हूँ. Is it clear? Fine. Sometimes sign flag को भी negation flag like N से denote करते हैं in some questions. Okay, fine. Depending on the question you have to understand that. Right. So these are all called as condition flags. For certain arithmetic and logical operation में these flags can be modified. They may become 1 or 0 depending on the operation. And different instructions will have different what you call rules for modifying the flags. किसी instructions में flags modify होते हैं, किसी instruction में उनका value 0 रहता है, like this. Some instructions में predefined values होते हैं, like this. So there are different cases here. So I am just taking one simple arithmetic operation like addition operation, and we shall see how to find out this particular flags. Is it understood? Yeah. So control flags में क्या क्या है? So control flags में we have got direction flag, inter flag and trap flag. Is it clear? So these flags are most probably found in 8086 processor. okay, along with this overflow also. But the basic processor like 8085 में ये 5 फ्लैग ही प्रेजेंट है, ओके, लाइक 8085 CPU में है यहाँ पर, ठीक है. सो ये फ्लैग रेशेस के बारे में अभी आपको क्वेश्चंस मिल सकते हैं डिपेंडिंग ऑन द ALU ऑपरेशन. समटाइम्स डायरेक्ट क्वेश्चन दे मे आस्क, समटाइम्स दे विल गिव सम इंस्ट्रक्शन, देन दे विल आस्क यू व्हाट इज द स्टेटस ऑफ द flags. Is it understood? Yeah. So now let us take one simple question and see how to find the particular flag. Okay, I am giving you two questions. For example, say one more special purpose register, as you know, it is accumulator. Okay, most of the CPUs may result is stored in the accumulator, right? So assume that accumulator has see, accumulator can be denoted by ACC or simply EA also. Okay, accumulator has got some value like 5F is the data and there is a register B. So B has got value, means the content of accumulator is 5F, the content of B is some, let us say assume it is some say like E7, okay, right. Now this is the given data. So now here let us see what is the status of flags which is possible for this particular sum of these two data. For example, if accumulator content plus B content are added, okay, if A plus B is done, then status of these flags, for example, what is the status of different flags? Status of, so I am just giving you only two flags like 3 flags like sign, 0 and the which flag, overflow flag, but we shall calculate all the flags so that it will be a practice question for you, okay, fine. So what is the status of these flags? Let us say this is the question given to you, okay, right. So let us take this particular question and see how the values can be understood. Is it clear? Right, this is the question. So how to understand the status of these flags? Let us see. So the question can be either status of only one flag, the question can be status of one or more than one flag also, that is possible, कैसे भी हो सकता है. So based on this let us see. Yeah, yes Ishita, for byte addressable the answer may see, for byte addressable or word addressable doesn't matter, क्योंकि previous question में Ishita there are two types push operation, two type pop operation, so answer will not change, unchanged. Still answer will be same only, SP only in the previous question. Yeah, so tell me what is the answer now. So very simple, all of you solve the question and tell me what is the answer. What is the answer? Very simple. मैं generalize दे रहा हूँ आपको so that you can follow easily. Yeah, tell me what is the answer here. So I am just taking this question. 5F is the content of accumulator plus E7 is the value of B. So you need to add these two and find the flags. Okay, so after adding, let us say the result is stored in the accumulator again, and let us see how the flags are modified. So now tell me, F means how much? 15. 15 plus 7, 22. So F means the hexadecimal value, in decimal it is 15, right? 7 to 7 ही है, no problem. So 15, ये वाला 15 है, 15 plus 7. How much is the answer in decimal first of all? Then convert into hexadecimal. 15 plus 7 कितना हुआ? 22 decimal में हुआ है. So 22 को hex में convert करो. 22 को hex में convert करो. कितना है? 16 1s are 16. Remainder is how much? 6. So what is the equivalent hexadecimal value of this one? Of this 22, how much it is? So this equivalent hexadecimal is how much? 16H is the equivalent hexadecimal value. So therefore 6 1 is carry. What that is what we call it as auxiliary carry करके बोलते हैं. So 1 plus 5 is 6. 6 plus E का मतलब 14 है. 14 E का मतलब hexadecimal E का मतलब decimal में 14 है. So 14 plus 6. 14 plus 6. How much it is? 20. 20 decimal में. But in hexadecimal what is the value? Let us say ये the result is stored in the accumulator only. Accumulator is 8 bit register समझते हैं, ठीक है. So now tell me 20 का hexadecimal value. How much is the value of 20 in hexadecimal form? 14H. Are you getting the point? So 4 1 is the carry out of register आया है. So this 1 is the carry flag. So carry flag will be 1. So 1 is carry out of the MSB bit. So carry flag is 1. So the result in the accumulator is 46 and carry flag is 1. Fine. So now let us see how the flags are modified, what is the status of flag. इसमें आपको कोई भी flag पूछ सकते हैं, मैं बस आपको randomly ये 3 flag लिया है, but here it can be of any flag also. So now let us see what is the status of flags. So sign, 0, auxiliary carry, parity, carry and overflow. ठीक है, let us see. Now ये बताइए, first of all 46H is the hexadecimal form. पहले इसको binary में लिखो. What is the binary value of this one? 4. What is the 4 means? 0 1 0 0. What is 6? 0 1 1 0. This is the binary form, right? So from this you should know how to find out the flag status. हर एक flag का rule होता है, वो rule आपको समझना चाहिए. Very simple. Sign flag will be equivalent to MSB. 0 है तो 0, 1 है तो 1. You know it. So 0 है तो result positive बोलते हैं, 1 है तो result negative बोलते हैं. Is it understood? Fine. So it is 0 means sign flag is also 0. Did you understand? Because you have 15 plus 7 22, that is 6 1 carry, again 6 plus 14 is 20 decimal means 1 4 4 1 carry. Got it? So sign flag is simply MSB of the result, right? Next one, 0 flag, overall result is a non-zero, so this overall result is not equal to 0 and hence 0 flag will be 0 only. 0 flag negative sense है, पॉजिटिव सेंस का मतलब क्या है, डायरेक्ट है, लाइक कैरी फ्लैग, कैरी आने से 1 है, नहीं आने से 0, बट 0 फ्लैग रिवर्स है, नेगेटिव सेंस है. रिजल्ट इज 0 मींस इट इज 1, रिजल्ट इज अ नॉन जीरो वैल्यू मींस 0 फ्लैग इज 0 ओनली. सो 0 फ्लैग विल बी 1 ओनली इफ द रिजल्ट इज 0. आर यू एबल टू अंडरस्टैंड? इफ रिजल्ट इज 0 देन ओनली 0 फ्लैग इज 1. सो देयरफॉर 0 फ्लैग इज 0 ओनली. ऑक्सिलरी कैरी फ्लैग, व्हाट इज ऑक्सिलरी कैरी फ्लैग? 1. parity flag, how many binary ones are there in the result? So 1 2 3, 3 ones are there. So 3 value is an odd value, it's an odd value, right? So if the value is odd, then parity flag is equals to how much? 0. If the number of binary ones are even, then parity flag is equal to 1. So number of ones are odd, parity flag is equal to 0. Carry flag is out of the MSB. हम सोच रहे हैं accumulator, let us say it is 8 bit only. So therefore here the carry flag is 1. Right. Next, overflow flag you have to think very carefully. Very easy. See, overflow is calculated when the data is considered as a signed data. अगर data signed समझने से, then you should know what is a signed and unsigned. Signed means MSB bit we take it for the sign. 0 means positive, 1 means negative. Unsigned का मतलब no need to check any sign of the data. पूरा data को magnitude समझते हैं. Entire data is magnitude only. Are you getting the point? So therefore here depending on the question you have to understand. So what is the value now? Very easy. So what is overflow flag? So overflow flag, here it is a positive value, this one is a negative value. So overflow flag will be possible when you are adding two signed data. You have to verify two signed data. If two data, signed data are having the same sign, then only there is a possibility of overflow flag. So what is the data now? Are you getting the point or not? Understood everyone? Very simple. So what is the value now? Simple. Tell me what is the value. So here overflow कैसे देखते हैं? I am solving in other way also. Simple shortcut. Shortcut कैसे करते हैं? Shortcut. How it is a shortcut here? So shortcut means, see, look at 5f. 5f का binary pattern देखो. What is 5f binary pattern? 0 1 0 1 1 1 1. Now tell me MSB कितना है? 0. 0 means is it positive or negative? Positive value. E7H, is it a positive value or negative value? E means 1 1 1 0, 7 means 0 1 1 1. अब बताओ ये वाला 1 है, 1 है तो positive है कि negative है? Negative. So if you are adding two data values of different signs, then overflow will be 0. So therefore ये वाला positive है व negative है. Simple, बिना कुछ solve किए हम बोल सकते हैं overflow will be 0. राइट और आप अलग तरीके से भी कर सकते हैं. सो MSB साइन है, ये वाला मैग्नीट्यूड है. ठीक है, यहां तक ठीक है एवरीवन? अंडरस्टूड हाउ टू फाइंड द फ्लैग्स, राइट? सो लेट अस गो फॉर द नेक्स्ट वन. ओके, you just take till here. See, I am covering some questions which are like NAT type, because objective type very easily you can solve. So that is why I am covering some NAT type of questions. What is the answer? Overflow flag is 0. I told you shortcut. What is shortcut? If you are adding two data values, signed values of different sign, a positive value and negative value है, blindly overflow flag 0 लिखो. Okay, no need to worry. दोनों डेटा सेम साइन रहने से ही ओवरफ्लो का चांस आने का चांस है. ओके, सो यहाँ पर डिफरेंट है, नो नीड टू वरी. बट प्रोसीजर वे कैसे कर सकते हैं, लेट अस सी. ओके, फाइन. टिल हियर इट्स ओके, नो फाइन, राइट. So let us take in another way how to solve this particular overflow flag. ठीक है, how to understand this. So if you look at this data, overflow flag 5F का binary pattern 0 1 0 1 1 1 1 1. This is the binary form. Second one is E7. E means 1 1 1 0. 7 means 0 1 1 1. This is the binary form of both data. Understood, all of you, right? अब सुनो. So here till this bit, last bit, D7 bit, MSB bit is a sign bit. Okay, this is a sign bit. Sign bit, and these 7 bits are what? Magnitudes. This one is D6, so on, etc. This is D0. D0 to D7 is magnitude. D7 is a sign bit, right? Fine. So the magnitude should be present. Magnitude only 7 bits तक ही रहना चाहिए. If the magnitude is overwriting the sign bit, then you have to think about the overflow. हाँ, अभी solve करो. कितना है binary pattern solve करने से? 1 plus 1 0 1 1 plus 1 plus 1 1 1 1 1 1 plus 1 plus 1 1 1. So 0 1 again. 1 plus 1 is 0 1. 1 plus 1 is 0 1, and 1 plus 1 plus 1 is 1 1. So 1 and this one is 1. अब देखो magnitude से it has come to the sign bit, right? Fine. Next, 1 plus 1, how much? That is 0. 1 carry is out of that 8 bits, so carry flag is how much? 1 here. अब देखो, so there is a carry from D7 to carry flag out of D7 also. There is a carry from D6 to D7 also. If both are positive, see, you have to just perform an XOR operation between these two carries. The carry means last Cn minus 1 and Cn means nth carry. Last carry कितना है? 1. What is Cn minus 1 carry also? 1. ये वाले 1. So ये वाला 1, this carry XORed with this carry means D6 to D7. XOR operation of 1 and 1, how much? 0. And hence we can say overflow is 0. अगर इन दोनों का XOR operation means the Cnth carry means this is, see, for example यहाँ से add कर रहे हैं carry 0, carry 1, 2, 3, 4, 5, 6, 7 means this one is C7 carry, this one is simply C6th carry if you are adding all the bits at a time. So इन दोनों का carry देखना है, ये वाला. So C7th carry and C6th carry here. Are you able to understand? So if you take from 1 8 आएगा, if I take from 0 ऐसा आएगा, because यहाँ से carry 1 2 3 4 5 6 7 8 आएगा. अगर if you take for 8th one, it will come like this. You can take anyway. I am taking from 0 or I am taking from 8th one. So ऐसे ले रहा हूँ मैं. This is C8, this is C7, right? Because I am taking carry from first 2 bits is called as C1. ऐसे सोच रहा हूँ मैं. So this is from here to here C1, from here to here C2 like this. C1 C1 C2 like this. C8 बनेगा. So C8 का carry and C6 का carry ऐसे लेते हैं, so that it will be without any confusion. So C8 carry and C7 carry दोनों 1 1 था, so therefore it is 0. So 0 आने से overflow आएगा, अगर ये वाला 1 आने से overflow. So if this is 0, then overflow will be 0. Okay, and if this particular, sorry, 1 minute. So if this particular XOR operation value is 1, then overflow flag will be 1. So a actual rule है, मैं आपको shortcut बताया here. Shortcut क्या था? If the two data values of different sign are added, then overflow will be 0. मैं directly आपको बता दिया यहाँ पर shortcut में. Okay, fine. Like this, 2 cases are possible. So whenever he wants to make a higher level of question, depth level of question, he will go to the overflow flag. Normally he may ask remaining 5 flags. Got it, everyone? Clear? Yeah, result of these two is 46. इन दोनों सम का रिजल्ट 46 है, बट फ्लैग का स्टेटस ऐसे करना है. एवरीवन अंडरस्टूड? साइन फ्लैग इज MSB, जीरो फ्लैग इज बेस्ड ऑन ओवरऑल रिजल्ट. इफ इट इज नॉट इक्वल टू जीरो, जीरो फ्लैग इज 1. If it is equal to 0, then zero flag is if it is not equal to 0, then zero flag is 0, and if the result is 0, then zero flag is 1. Fine. And auxiliary carry is lower nibble to higher nibble. Parity means number of binary ones in the result. अगर ये number of binary ones odd है तो 0 होगा, even है तो 1 होगा. Carry flag means MSB, बाहर, MSB से बाहर जो कुछ भी आया है, that is called as carry flag. Is it clear? So like this we can understand the flag status. Fine. Hope everyone is able to understand this. Clear? Good. Yeah, we'll solve one more question on the flags. If you are able to understand, try to solve the question. Okay, right. Hope you are able to understand, everyone, right? Next question. Next question. Find the status of 0 and carry flags for the following sum. Okay, so most probably they will give you addition operation, or subtraction also is done by a plus of minus c minus b, some values. If you take two values, processor के अंदर subtraction कैसे चलता है? a plus of minus b, instead of a minus b, a plus of minus b. So both are possible here, right? So let us assume that this is a question. So accumulator contains some data. Let us say accumulator has got some 9bh, and the content of c is given as say 65h. Okay, this is the data given to you. So you have to find out what is the status of these two. I am giving you some options, sign and 0. So sign flag will be say here 1 and 0 flag is 1, B option is 0 1, and C option is 1 0, and D option is both 1 1. You tell me what is the correct answer. Find out. These are very frequently given questions. Okay, try to solve it, please, everyone. I am giving you some NAT type of questions, because theory type of questions are very rarely asked in this subject. Most of the questions will be like numericals or analysis type of questions. So that is why I am trying to concentrate those topics especially. Option A. Okay, let us see. Remaining people, try to answer the question. Many people are there. I want response from you, everyone. So some people are answering the question, some are just watching the answers. Okay, I want everyone to involve so that it will be good practice for you. Okay, some people gave A, some people gave B. Let us see what is the correct answer. Yes, okay, right. So very simple, very quickly let us solve this question. What is the answer? B means how much? 11. 11 plus 5, 16. 16 means in hexadecimal form how would you write? 10H. 0, 1 carry. Okay, that is 10H. Okay. Next 1 plus 9, 10. 10 plus 6, 16. 16 in hexadecimal form 10H. So means 10H 0, 1 is carry, so carry flag is 1, right? This is the result. This is the result. So this result is stored in the accumulator. This is the result, right? So from this result we have to find the status of these two flags. Okay. Now expand this result in the binary form. What is the value? You get 0 0 0 0 0 0 0 0, right? This is all simply binary form. Now what is the status of flags? Very simple. He is asking about only two flags, but we shall try to practice for all the flags. Sign 0, auxiliary carry, parity, carry. These are basic flags which are given. Okay, right. Even you may have you can calculate overflow also. We'll see. You can practice that later. Now, how to find the flags? Tell me now. Sign flag is just based on the MSB. This is called as most significant bit of the result. This is called as least significant bit of the result. So whatever is MSB, that is sign flag. If it is 0, sign flag is 0. If it is 1, sign flag is 1. Next, look at the overall result. Overall result is 0. If the overall result is 0, then 0 flag is 1, because 0 flag is negative sense. 0 flag will be 1 if the result is 0. So therefore what is 0 flag? 1. Auxiliary carry. So whatever is obtained from lower nibble to higher nibble, that is called as auxiliary carry. From MSB to outside इसको बोलते हैं carry, but from lower nibble to higher nibble it is called as auxiliary carry. So what is the value? That is simply 1. Next, parity. How many ones are there in the result? No ones. So result has 0 number of ones. 0 number of ones. So now tell me, 0 is, if you take an even value, 0 is even value, then parity is taken as 1. That's all. Is it understood? Yeah. So therefore parity is how much? 1. Next, carry is how much? 1. Okay. These are status. So I just gave you two flags here, but they may ask you about any of the flags. That's why I just calculated for everything. So sign flag is 0, result is 0, so 0 flag is 1, auxiliary carry is 1, parity is also 1 because there are no ones in the result, take it as even, so that is 1, and carry flag is 1. Like this you can find out the status of flag. So what is the correct answer? He is asking about two flags, that is sign flag and 0 flag. Sign flag and 0 flag is 0 1. So correct answer is option B. Correct answer is option B. Got it, all of you? Clear? Right. Everyone understood? Clear? Like this you may have different questions to find the status of flags. Right. Okay. Right. I hope everyone has understood the question. Clear? Right. Next. Any doubts? If you have any doubts, you can ask me till this point. So I appreciate your answers. So whoever is responding, really appreciate your responses, because if you practice, you'll get confidence. Okay. And if you do error also, you can correct it now, not in the exam. Okay. Always practice number of questions. Grade requires lot of practice. It's not like theory subject. You have to keep on practicing. कितना practice करोगे उतना confidence level बढ़ते जाएगा. And whatever the errors or mistakes you want to make in this mock tests and these practice tests. So main test you have to perform well. Okay. At least some for electronics people, at least 1 month is left. I think February 15th, right? So based on that you try to practice the questions. Got it, everyone? Yeah. So now we shall discuss about some questions based on the exception handling, or in other words say interrupts. Clear? Right. So interrupts. So interrupt is an essential part for a CPU, because IO device can communicate with the processor by using the interrupts only. So different interrupts, as you know, it is maskable, non-maskable, vectored, non-vectored, okay, and hardware, software. There are different type of interrupts based on the CPUs. Okay, fine. Now we shall take one simple question. I hope everyone is following, right? Okay, I am just checking your status. Okay, because there is no direct link between us, so only message is the medium through which we can understand your status from me or through you also. Okay, right. So now let us take into consideration some questions based on the interrupts. That is also one of the important topic. So if you take a basic processor like 8085, there are 5 hardware interrupts and 8 software. Similarly, to store that interrupt service routine program, 8 bytes can be allocated or more number of bytes are possible based on the CPU. Right. In 8085 basic processor, trap is the highest priority, which is non-maskable. Remaining 4 are RST 7.5, 6.5, 5.5, INTR, like this. There are different type of interrupts. So now for a particular interrupt, when it is executed, what is the sequence of steps taken by the CPU? If you understand that question or process, you can answer any question on the interrupts in a very simple way. That is the point to note. Okay. So to answer these questions, you should know first of all what is the sequence of steps taken by the CPU to respond a particular interrupt. Okay, fine. So let me just tell you give you one simple question so that they can follow easily. Write the question. A CPU is interrupted at third instruction while it is already fetched inside CPU. Okay, right. As per following program. Okay. The value of content at top of stack would be, okay. So there is a note given here. The note is neglect the storage of flag status. Okay, fine. This is the given question. So this is the program which is given to you. So the program is starting at some address, say 300. There is some program here, instruction 1, some instruction 2, instruction 3, instruction 4, some instruction 5. There is some program here, right? So this is some instruction, and here the step size is how much you have to find out. Okay, so instruction 5 is halt. Okay, fine. So at instruction 3, after instruction 3 is fetched, then into the process, then interrupt has occurred is telling. So based on that you try to solve. So what is the answer? You must know. Option A, it is some 308. So these addresses are decimal values only, don't get confused. All the addresses are decimal values only because it's not hexadecimal. 309. Okay. Years whichever are there, it's a new subject, so you may expect at least 1 or 2 questions. Okay, but exactly we cannot predict now because it's a new subject, started in 2021 only, Sagar. Okay. So what is the answer? Yes, what is the answer? Simple question. Option B, let us see, some people are saying it is option B. Some people are saying option C. Okay, let us see then. If it is option C, let us see. Next. Yeah, I want answers from everyone. Okay, don't feel shy or don't feel like whether it is correct or wrong. You just respond the answers so that you can know how far you are able to follow and what is the level of your concepts, these things. Okay, don't worry whether correct or wrong. Just respond the questions. Okay, right, let us see. Okay, so when the processor or a CPU is interrupted, what are the sequence of events it will take? If you can understand these 2 points, you can easily answer any type of question in this. Now look at the question. So here when the question is given, this is the program, some program is there, okay. So instruction 1, 2, 3 like this, every instruction is one word. What is the step size? Tell me what is the step size now. Step size is equals to how much? It's a byte addressable memory, right? So 32-bit is the word length because step size is 4. So step size is how much? 4. Step size is simply 4. How do you know step size? Difference between two addresses, if you do, you will get the step size. Means the memory is having 32 bits in one memory location, but it is a byte addressable memory. Every byte will have one address. That is what you should understand, right? Fine. So this is the question. Now observe carefully. When a processor is interrupted, what are the sequence of steps? क्या sequence of steps होते हैं उसको समझना important है. What are the sequence of steps? So from this you can understand the answer. Okay. Okay, 1 minute. Okay. So let me just write here. So this is the basic concept. Sequence of steps taken by CPU while responding an interrupt. While responding an interrupt. Now very simple. See, some program is running. Now tell me what is the instruction I1, I2, I3, I4, I5. 5 instructions are there. He says the last instruction is halt. Halt means stop the execution, right? So this is instruction 1. Where it is starting from, which address, कहाँ से शुरू हो रहा है instruction बताओ, 300 से. So ये वाला byte addressable memory करके समझना चाहिए, ठीक है, right? So question कहाँ से शुरू हो रहा है instruction 300 से. ये कहाँ पर है 304. ये कहाँ पर है 308. Step size is 4. Okay. ये कितना है 308. ये वाला 312. Sorry, hex नहीं ना, decimal दिया था. Don't worry. ये डेसिमल ही दिया था, सो नो नीड टू वरी. एंड 312, दिस वन इज 316. अब देखो, आपको इंटरप्ट में कोई भी क्वेश्चन पूछे फर्स्ट ऐसे लिखो. Okay, now when the processor interrupted, there are 2 important steps. Now tell me, question में क्या बोला था? He is telling that whenever it is executing instruction 3, then some interrupt came. So what are the sequence? What is the value of data at top of the stack? See, he has also given one point like neglect the status of flags. So interrupt में क्या होता है? First of all, you should know. See, microprocessor is executing some main program. There is some main program which is being executed by the processor. Some main program is there. So when the processor is interrupted, it has to go to some subroutine program. That subroutine program is somewhere else in the memory or कहीं address पर है. So that is interrupt service routine, or you can say interrupt subroutine, whatever it is. So I am just writing ISR. ISR stands for interrupt service routine. This interrupt service routine is present at some address. Okay, some interrupt का vector locations पर है. Assume that vector location is some 4004, something like this. यहाँ पर है, and 408, some 4012. ऐसे some don't take hex value. Sorry. So like this, the interrupt service routine means application program of interrupt is present in somewhere else in the memory, right? Okay. Now there are very two simple steps you should follow for the interrupt. When a processor is interrupted, the first step, देखो program ऐसे चल रहा है. Now when the instruction was already fetched into processor, means the next instruction is I3. It is fetched, decoded while it is executing. So at that time, let us say interrupt has come. अभी interrupt आया है. So when the interrupt has been detected at this place, whatever is the instruction now present, it will first completed. It will be first finished. Then tell me program counter contains address of the next instruction. Okay, so the program control should be shifted from the main program to the subroutine address, some value, some subroutine address 4004, whatever it is. After completing its ISR, normally the last instruction will be written or I written, interrupt written. It will complete that. Again it has to come back to the main program. यहाँ पर आना चाहिए. Then it has to continue. ऐसे आना चाहिए. But microprocessor is a device. हम कैसे सोचते हैं? Device को भी ऐसे ही बनाया है. If you are going from your home, okay, you're reading some book and so something, so before you got a phone call to move outside. So generally हम क्या करते हैं, while you are reading a book, whatever, let us say this one book, okay, with me there is some notebook, okay, I am solving something, so whatever I am writing, वहाँ तक क्या हुआ था, in the meanwhile I got a phone call, so मेरा topic खत्म नहीं हुआ, I'll put a mark, pen as a mark, then I'll go outside, again come back. अब बताओ, why did I put the pen? Because I have to come back and continue from there. In the same way, the processor also, while it is executing a main program, it has to shift from the main to the subroutine program or interrupt service routine. So therefore interrupt service subroutine बोलते हैं इसको, ISS, interrupt service subroutine or interrupt service routine. It is present at some address of the memory. वहाँ पर कुछ ना कुछ program है, some program is there. So when the processor is interrupted from main program, what happens? Step number one. What is the first step? First step है number one. Program counter value, whatever is there, it is automatically pushed on to stack. So automatically program counter is pushed on to stack. Number two is flag status is also pushed on to stack. Flag status is also pushed on to stack. But question में क्या बोला था? Neglect that flags are pushed on to stack बोला था. इसको भूल जाओ बोला. ठीक है, that is first one. Second step is now the or we can say if you take 1 2, third one is this one as it is, whatever it is. So then it will go to the interrupt service routine program, then execute. So अब बताओ क्या होगा? When the processor is interrupted, tell me which content is pushed on to stack now? Program counter value is pushed on to stack. So stack pointer का value कुछ नहीं दिया है, so don't worry what is the value of stack pointer. Some value, SP value something is there. Okay, some value is there, some address. Already some previous tempo data is there. So the first step is program counter का value जो 312 था, ये वाला वैल्यू पुश हो जाएगा स्टैक में. सो ये एक्चुअली बाइट एड्रेसेबल है. सो एसपी में जो कुछ भी स्टेप साइज एसपी -4 पर स्टोर होगा. एसपी में कुछ भी एड्रेस रहने दो. सो दिस प्रोग्राम काउंटर वैल्यू इज पुश्ड ऑन टू स्टैक. सो 312 this 8 no, so next address is pushed on to stack memory. So that is the first step. Say he's asking what is the data at top of the stack memory. ये वाला अगर आप stack समझने से, if it is a stack memory, so this is first step. Second step is program control is transferred to the interrupt service routine, means application program address. Fine, right? So I'm assuming some address here. So therefore अभी answer कितना हुआ? He's asking what is the question here? What is asking? The value of content at top of the stack would be, he's asking. So what is the value of content? So top of the stack will be this value. Next instruction address will be at top of the stack memory. That's all. Very simple. Got it? Option C is the correct answer. So these two steps are very important. PC value is pushed on to stack. Flag content is also pushed on to stack automatically. Second step is program control is diverted to vector address of the interrupt. Some interrupt. Okay, right. So the answer is top of the stack will be 302. So option is how much? What is the answer? A, B, C. Which one? Option C is the correct answer. So like this you'll have different questions on the stack memory. The interrupts. This is important part to follow. Got it clear everyone? Fine. See, the same question can be asked in other way also, like he will tell that instruction 3 is a call instruction. Okay, same question he may say that instruction 3 is a call instruction. Okay, so with respect to call instruction or the interrupt sequence of steps are same, only difference is that let us say instruction 3 call hai, interrupt nahi hai, call hai samjho. So when call is executed means same, next instruction address is pushed onto stack, but second step is also same, but flags are not automatically pushed onto stack. हमें अलग से लिखना पड़ेगा some instructions in the subroutine program so that you can save the flags. That is the basic difference. So with respect to interrupt, next address is also pushed onto stack, flags is also pushed onto stack automatically, but with respect to the call instruction, flag status is not pushed onto stack automatically. You have to write a separate instruction program to save the flag status into stack memory. So that is the point to understand here. Okay, so I say interrupts ke बारे में, this is one good question which can be expected. Is it clear? Right. So like this you can follow. Okay, so the basic point you need to follow here is with respect to call. For example, मैं आपको ऐसे ही दिया question. So instruction 1, instruction 2, instruction 3, some instruction 4, instruction 5. So ये 300 है समझो, ये 304 है, this is 308 and this is 312 and this is 316. Let us assume like this. Okay, step size is 4 and the third instruction is call. They will tell you that the instruction is called call some subroutine SR1. So this subroutine SR1 is present in the memory at some 500, let us say. So 500, 504, 508, something like this. Okay, like this the program is there, some program is there. So when call is executed, what is the data at top of the stack, they may ask you. So when call is executed, same story, next instruction address program counter value step 1 hai, it is automatically pushed onto stack memory, but remember flag content is not automatically pushed onto stack, we must implement the program in the subroutine. So first step same hai, means the program ऐसे आके so ऐसे execute हो रहा था, the first step is the next instruction address is pushed onto stack, second step is program control is transferred to the subroutine address. So this one is label, no? Right. So it will go to this location, then it will execute the subroutine program. Interrupt में ISR बोलते हैं, interrupt service routine, here we call it subroutine, right? So normally in ISR or the interrupt service subroutine, the last instruction will be return instruction, so that you can come back to the main program again. So by the return instruction, you will come back from subroutine or interrupt service routine to the main program. From main program to subroutine आप कॉल से जा सकते हैं. So ये बेसिक डिफरेंस है. So इंटरप्ट के केस में फ्लैग को भी स्टोर करता है ऑटोमेटिकली, बट हियर कॉल में ओनली नेक्स्ट वैल्यू मीन्स प्रोग्राम काउंटर वैल्यू इज पुश्ड ऑन टू स्टैक. फ्लैग को स्टोर करने का रिस्पॉन्सिबिलिटी प्रोग्रामर का है. ओके, दैट इज अ बेसिक थिंग यू नीड टू फॉलो. क्लियर एवरीवन? या फाइन, great. Okay, now let us go for the next question. Clear? Right. Hope you are able to understand this. Next one. See, by the way, you have some time, so you can copy the questions later on if you are missing something while writing. So आप बाद में कर सकते हैं. Next is like we'll go to the next question. See, instruction format. Every instruction will have two parts: instruction code, that is opcode, and operands. Operand can be within a, it can be explicitly present or implicitly present. Implicit means instruction में operand field will not be there. Operand value and the opcode value, everything will be included in the instruction code only. But some instructions may opcode will be different, operand values will be explicitly present in the instruction, as you know. So therefore here instruction format will take some questions based on the ISA. Before that, let me just tell you one concept of instruction format. Already you know this, but I am just giving the question. So instruction format, instruction will have two parts, opcode and operands. Okay. So in some instructions the operands opcode can be together present, that is called as like operands means the data on which data operation has to be performed. Opcode means operation code, means the meaning of instruction, what kind of operation is required, move, like ALU operation, which operation, branch operation, machine control operation, कैसे करना है, right. So operands means data on which the operation has to be performed. So operands means the addressing information of data, addressing information of data. So data कहाँ पर है, data register के अंदर है, data memory में है, okay, data IO से आ रहा है, what is there, what is the address of data, so from where you are getting the data, so that the information is given by operands. So this operands can be present implicitly or explicitly, okay. So based on that there are different type of questions. You can get a question on addressing mode, you can get a question on finding the meaning of instruction, okay, what is the effective address. I said different type of questions are possible, okay. We shall discuss about those questions now, okay, right. Yeah, good. So some people are responding, right, fine. So here the instructions is the very first line of syllabus is machine instructions and addressing modes, है ना. So now we have come to the instruction part. So instructions में now we shall see some questions like some instruction will be given, you are asked to find out what is addressing mode. You may have a question of finding the length of program. I said different type of questions are possible. I am going with the basic question, then we shall discuss about the instruction set architecture, means depending on the operand storage, depending on the operand storage, कैसे operand store करते हैं, based on that there are different ISA types, like it can be stack based CPU or it can be accumulator based CPU or it can be general purpose register based CPU, okay. Based on that we shall see some questions here, right, very simple. Now let us take one simple question here. So from that question I will cover different types also, okay, fine. So let us take some simple question here. Okay, so say here the question is move R1 comma so LD means load, S means store. Okay, this is the program given to you. So from this there are different questions which are possible. Let us see how to understand this one, okay. So here so what is the instruction length, instruction length, one word, two words, one word, one word, and say, so this is halt, okay, halt, it is also one word, okay, fine. So there are different questions. Let us see how to understand these different questions. I am taking a simple example of program and how to follow different questions from the same program we shall discuss, okay. So the questions here are number 1, total length of program in words, okay. So from the same program we will see some linked questions, okay. Okay, what is the addressing mode of LD 1 minute, let me just change this one. 1 minute, you just take it as some address here. 1 minute, you just take this address as say some 400 instead of @r2, take it as 400, take it as 400. So little correction, you just take it as 400. Okay, till now we take just 2 questions, we will solve some more also based on this one. I am taking on some simple question to different type of other questions. Okay. Okay, clear? Done? Okay, you can copy the question later, right? So let us not waste time. Okay, see, there are different type of questions here. So there is some program given to you. So here the length of each instruction is given. So this instruction is 1 word. Okay, let us say this instruction is 1 word. He has given something like this. This one is 2 words. It is 1 word. Sorry, 1 minute. It should be 2 words. It should be 2 words because we have changed this. No, it should be 2 words. This is 1 word. This should be 2 words. Okay, and based on the question we have to answer it. Okay, this can also be actually 2 words. This can also be actually 2 words. If we take 2 words, let us see now. If we take 2 words, take it as 2 words. Okay, now tell me what is the answer. So first one, so this is some program. So this is some program. First question is very simple question. What is the total length of the program? अब बताओ ये program memory में कहीं पर store होगा ना? It will be stored somewhere in memory or not? Yes. So he is asking how much memory space this program will take. Very simple. What is that? Simply add all these words. That's all. It is because it's a value, operand value, and there is some register here to move. Okay. So he is asking what is the total length of the program. Tell me how much. It's a 2 words, 3 words. Okay. 3. It is 5 plus 6 plus 3, 9. So is there any answer here? 9 words? No. Okay, so assume that none is the answer here. Okay, because there is no 9 words. So total length of program, how much it is? 2 plus 1 3 plus 2 5 plus 4, 9 words is the total program length. Fine, 9 words. So there is no 9 words here, so none is the answer. Or if at all 9 words is given to you, that would have been the answer. Okay, fine. ऐसा आपको रह सकता है question. That is simple question, just finding out the length of program. Fine. Next one, here he is asking about one value. What is addressing mode of this particular instruction करके बता रहा है. So first of all you should know what is the meaning of addressing mode. See, notation अलग अलग हो सकता है. Sometimes the question can be given like this. Sometimes the question can be given with a bracket also like this. Okay, and sometimes he will mention the question addressing meaning also, like, so you should know how to read the instruction. अब देखो, so first type of question is simply what is the total length of program. So everyone understood here, length of program very easy, कितना words दिया सभी को add करो, you'll get the length of program. That is very simple. Second type of question, different types possible है इसी में. Second type is like he may ask you the addressing mode of any of the instructions, right? Fine. Addressing mode का मतलब क्या है? What is the meaning of addressing mode? Addressing mode means for a particular instruction how the operands, or in other words data, is accessed for that particular instruction. So how data is accessed for that particular instruction, that methodology is called as addressing mode. So these addressing modes are various formats which specify the operands. Operand का मतलब क्या है? Addressing information of data. एक instruction के लिए data कैसे लाना है? That methodology is said to be what? Addressing mode. So there are different addressing mode: immediate addressing mode, direct addressing mode, register addressing addressing mode, register indirect, memory indirect, index addressing mode, okay, base and index, okay, base and index with some displacement, PC relative addressing mode, okay, implicit or implied addressing mode, auto increment, auto decrement, base register. There are different types of addressing modes, and every CPU may not support all addressing modes also. किसी में हो सकता है, किसी में नहीं हो सकता है. Fine. ये basic question है. Now let us see what is the question. So this question can be given like this, or it can also be given without the brackets also sometimes, depending on the type of question. Got it? Right. Now let us see what is the meaning of this particular question. Okay, observe carefully. So here the meaning of instruction, let us understand carefully. मैं आपका helpful to make it easy, I am giving you the addressing mode. Very easy. What is the meaning of this? Okay, this is addressing mode. I am just giving you addressing mode of each instruction. The meaning of instruction is move R1 comma hash. Wherever this pound symbol is there, this value is indicating data. इसका मतलब whichever is the instruction which has data in it, that is called as immediate addressing mode. So immediate addressing mode means data will be a part of instructions. 1 minute. Immediate addressing mode means data is a part of instruction. So the meaning is data R1 should have 25 in it. Okay, I am just taking decimal value. Next one. So the data from one register is copied to another register, that is called as register addressing mode. It means R1 content, whatever is there in R1, that content is copied to R2. So tell me what is the value of R2 now? Same 25 only, right? Next one. Here now LD R3 comma 200 मतलब क्या है? Load, LD stands for load the content from this memory location to R3. So 200 is some memory location, we don't know what is the data, some data is there. Is it clear? Right. So this content of 200 meaning memory में, in the memory there is some data in the 200, some data is there. Let us assume the data is some X value, or simply the data is some say 40 something like this. मैं randomly ले रहा हूँ so that you can understand easily. So memory में some data is there 40. So you have to load this 40 means whichever is there at 200 address into the corresponding register R3. So into R3 what is the content access now? 40. Right? Fine. So this which addressing mode now? Direct addressing mode. Direct addressing mode means address of the data is present in the instruction. So that is answer. So 200 is what? Address. He may give like this, or he may also give the bracket to this one. Square brackets, not the what do you call parenthesis. Parenthesis देने से memory indirect हो जाएगा वो, ठीक है? Right. So what is addressing mode now? It is simply direct addressing mode. Means data from this memory location is accessed into R3. So let us say assume that R3 is having some 40. Okay. Next. What is the meaning of this one? Add the content of R2 and R3. So now this 40 plus 20. I am just assuming some data. So R3 content plus R2 content को add करना है, and result is again stored in R2 only. It means this 40 plus 25 is added. The answer is 65. The answer is 65, and this result is again stored in the R2 only. That is the meaning. So destination is R2. So tell me what kind of addressing mode? Register addressing mode only, because here it is performed within the registers. Next one. What is the meaning of this? ST store the content of R2 at 400. ऐसे भी दे सकता है और square bracket ऐसे भी दे सकता है. मतलब this content result, that is 65 R2 result, is stored at a location. Which location you have to store into? 400. So in the 400 memory location, this 65 is copied. That is the final destination. So which kind of addressing mode it is? Direct addressing mode. Address of the data is present in the instruction. So halt is simply implicit addressing mode. Okay. Actually halt can have it is implemented by unconditional jump inside the instruction, but instruction does not have any what do you call the operands. We can call it as simply implicit. Or halt internally it is implemented by the unconditional jump instruction. So that is PC relative. Jump is a PC relative instruction. So as per the operands there is no operand here. We can take it as implicit, or if you talk with implied or implicit, or if you take with respect to jump instruction is a which one? PC relative addressing mode, because with respect to current value of program counter, it is running infinite loop for the same, मतलब प्रोग्राम का कंट्रोल यहीं पर रहेगा, इन्फिनिट लूप चलेगा, that is like unconditional jump instruction बोलते हैं. So that is if you take with respect to that. So there is no operand here, so we can take by with respect to that, no operands are there, so implicit addressing mode. Is it clear? Right. Fine. So that is how the data is there. So which kind of addressing mode is this? Direct addressing mode. Is it understood? Yeah. Hope you are able to follow. We will take some more questions on this addressing modes. Addressing modes are very important. We will take one more question on addressing mode, then we will go to next topics. Hope everyone has understood this. Clear, all of you? Right. Shall we go to the next question, all of you? We will take one more question on addressing modes, then we will go to the other topic called as the instruction encoding, okay, which are very frequently given questions. Okay, done. Right. Okay. Next question. What is the addressing mode of the or for the given instruction, for the given instruction for operand 2, for operand 2, and the content of destination register. Okay, fine. Okay, this is the question. Okay, this is the question. Clear? Right. So this is the question. So first one, he is asking about addressing mode and what is the result in the content of destination registry is saying. So first of all, you should know very clearly what is the meaning of instruction. Okay, fine. Followed all of you? Done? Can you tell me? So here you try to follow. In the question it is given as this is operand, this is operand 2 and this one is operand 1. So this entire thing is operand 1. Okay, fine. This is given in the question. You have to find out what is the addressing mode of operand 2, how to access the operand 2. Okay, right. Clear? That is given in the question. Clear? Okay, right. So let us see how to answer this particular question. So very simple. Here you should know the concept of memory thoroughly, then only you can solve this question. Okay. So what is the content given in the memory, you should know. Okay. So in the memory there are some addresses. Okay. So he is telling sub 20 R1 comma R2. So it is present in the parenthesis. So you should know what is addressing mode. He is asking what is addressing mode to access the operand 2 from memory. The operation is which operation here? Subtraction operation, right? Subtraction is the operation. Accepted, fine. But here you have to bring the first operand from another value, second operand from. So for example, say operand 1 is this one, second operand is this one in the question as per the question. Okay. So now which kind of addressing mode is having, the operands may have different addressing modes. Okay. So each operand का अलग अलग addressing mode होने का chance है. अब बताओ ये कौन सा addressing mode है? Tell me first operand कहाँ से लाना है? Which kind of addressing mode is for this operand 2? Okay. First operand ये बोला है question में, second operand ये बोला है. Let us say. So he is asking for which operand? Second operand. So आपको some arithmetic operation करना है, subtraction, by bringing this two data. Right. So now observe carefully. This is the second operand. You have to bring from the memory from the address that is stored in R2. So the second operand addressing mode is register indirect. So R2 में क्या content है, R1 में क्या दिया हुआ है? R1 contains 500, R2 contains 600. So here R1 contains 500 and R2 contains 600. Something is given for us, right? Fine. अभी observe करो. So here the second operand addressing mode, the second operand addressing mode is called as register indirect. Register indirect. What is the meaning of register indirect? Whatever is the content of register, from that register you have to bring some data into the which one? Into the register, into some as a second operand. It is stored in the temporary register. The other operand you have to bring from this addressing mode. ये कौन सा addressing mode है? Index addressing mode. Are you able to understand? So here what is the value? Index value is how much? 20. So R1 is having some value. So first operand का addressing mode है index addressing mode. Index addressing mode. Second operand का addressing mode है register indirect addressing mode. So now what is the effective address for this one and what is the effective address for this one? So tell me, for the second one the effective address means what is the actual address of the data. Data कहाँ से लाना है? That is what you have to understand. Okay, see this addressing modes definitely आपको questions पूछेंगे addressing modes में. These are frequently given questions. अब बताओ. So आपको subtraction करना है two data values का. First data को एक जगह से लाना है, second data को दूसरी जगह से लाना है. So from where you have to bring, कहाँ से लाना है, that particular address is called as what? Effective address. So effective address of second operand is different, effective address of the first operand is different. Understood? So this one is index addressing mode, this one is register indirect addressing mode. Register indirect means, so tell me what is the effective address for this one? For this second operand, what is the effective address? Effective address is simply content of R2. So tell me what is the content of R2 given? 600. So 600 is the effective address of data. It means in the memory at some 600 location some data is there. What is the data? He told at 600 200 is present, data is already present. Matlab memory content of 600 is 200, means at this location 200 is there. Got it? Right. Next one, R1 contains how much? 500. So first data if you want to perform a subtraction operation ALU mein, so ALU mein let us say subtraction operation must be done. So this is ALU, right? So ALU mein subtraction operation is done. So first data means like operand 2 content यहाँ पर आएगा. What is this data? 200, right? Next, another data you have to bring into another part of another input of ALU. Let us say वो कहाँ से लाना? What is the effective address here? Addressing mode is index addressing mode. What is the effective address for the first operand? Effective address for the first operand is content of R1 plus this particular 20. So what is the content of R1? You have got 500 plus 20. 500 plus 20 is 520. So 520 क्या है? Effective address है. Means the first operand is present in the memory at some address called as 520. So what he says, the memory content of 520 is 70 is telling. Okay, memory content is 70, something like 70 like this. Okay, so this data, second data will also come into the ALU. So यहाँ पर operand 1 यहाँ है, operand 2 यहाँ पर है, A70 है. So now this is A input, this one is B input of the ALU. So what is the subtraction now? A minus B, okay, A input minus B input normally. So here he is telling and the content of the destination register. So destination register में क्या होगा? So first operand 1 is brought here. So this is operand 2 as per the question and this is operand 1, right? You have to subtract from this one, means operand 1 से operand 2 को subtract करना है. So very simple. So here 70 minus 200. So the result will be something like negative value. So some negative result will be there. Means अगर क्वेश्चन आपको डेसिमल में पूछने से it is simply 70 minus 200 is minus 130 आएगा, और in hexadecimal also you can simply ask the question. So simply it is minus 130. So result is in the decimal negative value, negative form. अगर डेटा उल्टा होता तो 130 आता था. So that minus 130 they may ask you to write in the hexadecimal form or binary form. You have to just convert into hex form, write in the binary form. Like this you'll have questions. But the point to understand here is that, so there are two questions asked. The intention of this question was, क्या intention था? How to understand the addressing modes. So this is called as register indirect addressing mode. Register के reference से, मैंने अब बताओ register में कितना है? How much it is there? How much it is? 600. 600 के reference पर data है. That is register indirect. You're pointing to the data from the reference of some register indirect. Okay. And other one was index addressing mode. So R1 content plus some value. Okay, index value. So 520 is the effective address. So effective address means what is the actual address of the data for that particular operation, right? So I said two operands को ला सकते हैं. Is it understood? Right. So that is answer. So answer will be minus 130 in the destination. So ये subtraction होने के बाद result कहाँ जाएगा? Always this is the destination. So this place only again it will be stored. It means again at 520 location whatever is the result, ये result हो जाने के बाद after the execution of the result, so this result is again stored at this particular location only. It means this minus 130 in the decimal form will be again stored at that particular destination only. Is it understood? So like this you can have different type of questions on the addressing modes. Okay, इसी में आपको अलग क्वेश्चन भी आने के चांस है. हाउ मेनी टाइम्स द मेमोरी कैन बी एक्सेस्ड फॉर दिस पर्टिकुलर प्रोग्राम करके पूछेगा. ठीक है, राइट. सो लेट अस सी हाउ टू आंसर दिस पर्टिकुलर क्वेश्चन. I am giving you one more linked question based on this data. Okay. Done? Right. So in the same question I am just asking you one more linked question. What is that? I hope you are able to follow this, right? आप बाद में copy कर सकते हैं, don't worry. One more question I am asking you based on the same data. So here number of memory accesses memory accesses for execution cycle of the instruction. Okay, right. So how many number of memory accesses are required for execution cycle of the instruction? So instruction is same instruction. So the instruction is sub at the rate R1 and this was R2. So this one is register indirect addressing mode. This this one was index, no? This one was index 20 R1. ये था instruction, right? So this was the instruction. Okay. Same instruction. Yeah, fine. So observe carefully. So for this question you should know how the instruction cycle or timing of instruction कैसे होता है, you should know. So these are all the next level questions. You should understand carefully how to solve that. Okay. So I am just mixing 2-3 concepts in the same question so that the time will be useful for you. Okay. अब देखो. Now the instruction is present in the memory. यहाँ पर है सोचो instruction. In the memory the instruction is stored, right? This is how the instruction is stored. Assume it is one word only. Assume that the instruction is given as one word instruction. Let us see. Sorry, not one word, 2 word instruction. Let us assume. Okay. Assume that instruction is a 2 word instruction. Okay. Word length कुछ भी रहने दो. Word length we don't know what is the word length. Some word. This is the word length, right? 2 word instruction means this instruction is occupying 2 memory locations. So this is the instruction first part, this is the instruction second part. Let us say this is the meaning of 2 words, right? Fine. Now here there are 2 effective addresses. For this one to bring the first operand or the second operand, whatever it is, for operand 1, operand 2, no, as per the question, operand 2 ka effective address is different 2, and for operand 1 the effective address is different, that is different. Are you able to follow? So this is one effective address and this one is another effective address. Are you able to understand? So 2 effective addresses are there. It means from the memory you need to get the 2 operands. So 2 operands are there here. Okay. So this is some effective address 1. Let us assume like this. This is some effective address 1 and this is some effective address 2. Are you getting the point? Right. 2 effective addresses are there. So it means the first operand means the data 1 is present here, data 2 is present here, right? Fine. So for this particular instruction, how many memory accesses are required for execution cycle? So for that you should know what is the meaning of instruction cycle. Instruction cycle is equals to fetch cycle plus execution cycle. FC means fetch cycle, EC means execution cycle. Execution cycle. So execution cycle is again 2 parts. One is decode cycle, other one is the execute cycle, or you can say execution cycle also, execute cycle. Okay. So what is the meaning of this? Fetch cycle means till the opcode is fetched into the microprocessor or a CPU. So instruction 2 words का 1 word ने 2 words बोला है, let us say instruction. So एक कैसे करना है, a little bit of higher level of question. So 2 marks questions can be possible like this. Okay. So कैसे solve करते हैं? Very simple. अब बताओ. Very easy. First one बताइए. First one, any instruction का for any instruction first operation कौन सा है? Opcode fetch only. Memory से fetch opcode fetch करो, data को fetch करो, memory access ही बोलते हैं. Memory को data भेज रहे हैं to send the data, that is called as memory write, but in general that is called as memory access. So memory access may involve an opcode fetch, memory read, memory write, anything. If you are selecting a memory for some operation, that is called as memory access. Got it? Right. So अब बताओ, first of all for any instruction, this instruction must be fetched. So this fetch cycle, so till this opcode is brought into the microprocessor, that is fetch cycle. So you are accessing the memory one time for the fetch cycle. So one memory access, I am writing MEM means memory access. But question किसके बारे में पूछा? He is asking about the execution cycle. He is asking about this one, right? If the instruction, अगर instruction एक ही word होता तो then one memory access for the fetch cycle. So this is one memory access only, one memory access. But now tell me, instruction is 1 word or 2 words? 2 words. Means after decoding the instruction, after opcode fetch, this instruction will be decoded, right? After decoding only, it knows whether it is a one word instruction, two word, what to be done, everything, addressing mode, everything is understood only after decoding. So after decoding it understands that it is a two word instruction. It is a two word instruction. Two word instruction matlab one word is already completed, the second word should be brought from memory. So if the instruction is more than one word, the instruction is more than one word, and when you are accessing the data, so these all come. So decode cycle is effective to just bring the remaining parts of instruction. मतलब two word instruction है, first word आपको ला दिया, that is opcode, fetch cycle खत्म. Decode cycle means to bring the next part of instruction. How many parts are there? Instruction opcode है, उसके बाद operand है. So this one. So you have to bring this two. Okay. So based on the question he has given, it is a two word instruction. So therefore to bring this one, the second part of instruction, you require one memory access. Okay, right. So tell me, this one will come under the decode cycle. So one memory access to bring the second part of instruction. Oh, sorry, one memory access is required for the second part of instruction. Are you able to understand, everyone? Right. So this one memory access is required. Now यहाँ तक ठीक है, but after this one, whatever is taking place, everything comes under the execution side. This one only. अब बताओ, is the data directly available in the instruction? No, it's not immediate addressing mode. First operand अलग है, second operand अलग है. So first operand के लिए you are accessing memory one time, one memory access, right? Fine. To bring the second operand into the processor, you are accessing memory once again, second memory access to this one and this one to bring the data. Then finally you are performing the subtraction and execution में क्या कर रहे हैं? This result is again stored at the effective address 1. So whatever the result is there, that result, whatever is obtained, this result is again stored at this particular address only. So this is another memory access. So tell me now, for decode cycle one memory access, remaining all whatever is there, that will come under the execute cycle. So how many are there? 1, 2 and 3. So total 3. So this is one memory access, two memory access and the 3. So 3 memory access are required. So now tell me, is he asking about fetch cycle or execution cycle? Execution cycle. So for execution cycle, total how many memory access are required? 4 memory accesses are required. That is the answer. 4 memory accesses are required for execution cycle. Is it understood? So decode cycle will come into picture only if the instruction is more than one word. So अगर instruction 3 words होता तो first one is fetch cycle, 2 will be 2 memory access for the decode cycle. After decode cycle means to bring the total instruction अंदर आने के बाद, right? Then how many next access are there? They all come under what? Execution cycle only, right? So like this you can have 4 memory access. Got it, everyone? Yeah. So these are second level questions. Okay, advanced level questions. Next. Okay, right. Hope you are able to understand this. Clear, everyone? Okay, right. Fine. Now let us discuss one question we shall discuss about the instruction encoding. So there are two types of instruction, fixed length instruction and variable length instruction. So variable length instruction, it can support more number of operands. Fixed length instruction supports only few number of operands. Okay, fine. So RISC is the best example of fixed number of fixed length instruction. So in RISC means reduced instruction set computer. Okay, fine. So RISC may it supports only fixed few number of operands, but the advantage is that you can have more number of instructions of different types. Okay, that is advantage. Is it clear? Right. So you can increase the number of lower order instructions in case of fixed length instruction. Is it clear? So इसको बोलते हैं opcode expansion technique. So therefore one feature is present in the fixed length instruction that is called as expand opcode technique or opcode expand technique, opcode expanding technique. It means that the number of lower order instructions can be increased. What is lower order, higher order? How many number of operands, कितना operands instruction में है, 1 operand है, 2 operands है, 3 operands है, ऐसे. Okay, so based on that, so if it is no operand in instruction, that is 0 address, 1 operand is 1 address, 2 operand is 2 address, 3 operand is 3 address instruction. Is it clear? So operand का address को ही number of addresses करके बोल सकते हैं, order of the instruction करके बोल सकते हैं, right? So now let us take one simple example here. So to make it simple, I am just giving you a question. Try to understand this. For example, एक instruction CMA complement the content of accumulator. There is no separate explicit value for the operand. Operand address अलग से नहीं है. So this instruction is called as what? Zero address instruction. Zero address instruction. For example, I am writing like this. Let us say accumulator based architecture में add B करके दिया. Let us say B is the address of some register name. कुछ भी हो सकता है, address, register name, anything that is taken as one address. Apart from the opcode, one operand field is there, that is called as one address instruction. And I am writing as add R1, R2. Two register fields are there. We call it as two address instruction. I'm just writing in shortcut, right? And for example, the instruction may also have three addresses, I, R3, R2, R1. Okay, इसका मतलब क्या है? R1 plus R2, result is again stored in the R1 only. That is the meaning. And here what is the meaning? R1 plus R2 and result is stored in the sum of these two is stored in R3. So how many fields are there in the instruction? The field can be a register name, the field can be memory address, anything. That is called as address or simply order of the instruction. Okay, so here this is called as what? Three address instruction. Three address instruction. I hope you are able to understand this. Clear? Right. Now here this is how simply we take it as different orders of instruction: 0 address, 1 address, 2 address and 3 address. Now here the point to note is when the instruction is prepared for a CPU, it can be like fixed type of instruction, fixed length instruction, it can be variable length instruction also. RISC में fixed length instruction follow करते हैं. For example, 3 address instruction, most of the instructions will be 3 address only, but number of depending on the type, like for example lower order अलग अलग हो सकते हैं. Instruction length fixed है, but that instruction length may have either 1 address of the operand or 2 address or 3 address, whatever it is. Like this, that is called as expand opcode technique. What is the meaning? Let us see now. Fine. So let us take one simple question here. Fine. So let me tell you one simple question here. Okay. This is the question. So a CPU is there. A CPU supports 16-bit instruction format. CPU supports 16-bit instruction format. Okay, and the address field size of address field is 4 bits. Size of address field is 4 bits. Okay, then the computer uses opcode expand technique. Computer uses opcode expand technique. Okay, and has 42 address instructions and has 42 address instructions, and let us say 101 address instructions, 101 address instructions, 101 instructions. You can copy the questions later on. Okay, just listen. And he is asking what is the total number of 0 address. So how many number of 0 address? So what is number of 0 address instructions that can be supported? That can be supported. Okay, fine. This is the question. Let us say it is an NEAT question, okay, numerical type of question. Okay, let us see. So these are very frequently given questions. A question, ऐसा वाला question this year also has given. Okay, how to solve this particular question? Very simple. It is a just game of 2 power n. That's all. This is the question. Okay. So based on this, let us see. So with this particular basic insight, we shall discuss this particular question. Okay. So let us take this an idea. Did you understand the question? His CPU supports 16-bit instruction format. Size of address field is 4 bits, and the computer uses opcode expand technique and has 42 address instructions, 101 address instructions, and what is the number of 0 address instructions that can be supported. So tell me what is the higher order here. Instruction higher order कौन सा है? 2 address. So instruction का format अच्छी तरह समझो. So this is a fixed length type of CPU, means instruction will have fixed length, लेकिन the number of operand fields can differ. Okay, fine. So that is what we can understand. So क्या बदलना चाहिए? Operand fields differ मतलब opcode का field बदलना चाहिए, इसलिए opcode field of the instruction is variable. Expand opcode technique करके बता रहे हैं. Okay, right. So what is the format of this instruction? Let us understand carefully. So this is the format. Okay, observe carefully. This is the format, right? So what is the higher order it can support? It has got 2 fields. Okay, this is one field. Let us take both are some address field. Okay, some address field is there. Okay, register name हो सकता है, maybe add anything. Address field 1 and address field 2. 2 addresses are there. What is the total length of this is the opcode. So any instruction will have the opcode field and the operand fields. Okay, so total length of instruction कितना bits बोल रहा है? 16 bits बोल रहा है. Okay, 16 bits. Now he is telling that if it is supporting the opcode expansion technique, then how many 0 addresses are possible? Very simple. ये question है, ठीक है? So tell me what is given to you. 2 address instruction, T is equals to how much? 2 address, T is 2 address instructions are how much? So you can understand easily, 2 address instructions are how many? 40. 1 address instruction कितना है? 100. 0 address instructions कितना है पूछ रहा है. How many is asking? Okay, very simple. How to solve this? So first of all, what is the methodology to solve the question? Very simple. Let me solve here. Solution. Fine. So each address field. So tell me each address field is how many bits? 4 bits. This is also 4 bits. This is also 4 bits. Accepted? So tell me what is the opcode field length? How many bits? Definitely 16 minus 8, that is 8 bits. 8 bits will be the opcode field. First of all, ये आपको मालूम रहना चाहिए. Now to find out the procedure, how to find out this one? Okay, procedure क्या है? So therefore, you first find out what are the total possible higher order instructions. Tell me what is the higher order here? 2 address is the higher order. This is the higher order. Okay, this is the higher order. Higher order instruction. अब बताओ. If the opcode bits are 8, so 2 power opcode bits is the total possible higher order instructions. मतलब ये total CPU में 2 power 8 different type of instructions are maximum possible. If you are taking all are 2 address, सभी 2 address है तो इतना possible है. So 2 power 8 is equals to maximum, or we can say higher order instructions. Total higher order, that is 2 address instructions possible. Is it understood? Yeah. So how many are possible actually? 2 power 8 is equals to 256. 2 address are possible. इतना possible था, but how many are taken for this one? Only 40 are there. मतलब remaining codes 256 minus 40, how much it is? 216. 216 different other operations can be for lower order instructions. But with respect to 2 address, these 2 are lower order, no? So 1 address is how many again? 100. So remaining कितना है? 256 minus which one? The 216 minus given 2 address will be the total number of remaining 1 address instructions possible. So उसको देखना है. How many opcodes are left for the 1 address? Okay. So here we can write opcodes left for 1 address is equals to 1 address instructions is equals to how much it is? So total minus given 2 address instructions. Are you able to follow everyone? Clear? Right. So बताइए यहाँ पर, so you just find out what is the value. So total minus, so how much it is? Okay, let me write like this. So total is how much? 256. अगर total instructions 2 address का ही होता तो उस processor में 256 possible है, but this processor supports 2 address, 1 address and 0 address also. इसका मतलब बाकी के लिए भी number होना चाहिए ना, right? So total minus given 2 address. How much given 2 address? 240. That is equal to how much? 216 codes are left for 1 address. Now again only 1 address नहीं है अभी, 1 address भी है, 0 address भी है. It means these many opcodes are left, but how many 1 address total instructions are possible? That is what you have to understand. So total 1 address instructions possible, total 1 address instructions possible is equals to opcodes left into 2 power address bits. 2 power address bits. इसका मतलब क्या है? Here अब देखो, अगर ये 2 address है ना, right? So 2 address maximum कितना possible है? 256 are possible. But here he says only 40 are there. Maximum possible 256 है, but 40 given है. So it means if there is only 1 address, this address field can be appended to the opcode field. इसलिए इसको opcode expansion बोल रहे हैं. मतलब for 1 address instruction opcode bits कितना बन गया? 8 plus 4, 12 bits का opcode बन गया है, not 8 bits. For 2 address instructions opcode bits are 8, but for 1 address instruction opcode bits are 12 now. Did you understand? So therefore this remaining codes left off into 2 power 4 bits will be the total 1 address possible. मतलब ये 1 address है तो ये पूरा codes, number of codes left into 2 power. This address bits also will go to the variable value of what? This 1 address only. So therefore we can say that here how many opcodes left? 216. So 216 opcodes into how much? 2 power 4. Address bits कितना? 2 power. So these many total 1 address instructions possible है, but कितना है बोल रहा है? 100 ही है. Okay, so इतना instructions 1 address में only 100 are there. So remaining codes which are for 0 address you have to find out. So like this you understand. So opcodes for 0 address is equals to total 1 address instructions minus, sorry, let me write like this. Okay, total 1 address instructions minus given 1 address instruction. Did you understand? Yeah, given 1 address instruction. So how many total are possible? 216 into 2 power 4 are possible. Okay, so but tell me here, if at all only 1 address are there, these many are possible, but given are how many? Only 100 are there. So remaining codes whichever are there, these are the total number of opcodes left for the 0 address. Did you understand? So what is the total number of 0 address instructions possible? अब बताओ, total 0 address मतलब this opcode bits will be still expanded to this field also. 1 address के लिए opcode length is 12 bits. 0 address मतलब this address field also should be appended to the opcode. So now opcode will become how much? 16 bits opcode हो जाएगा. So this is a variable quantity now. It's just game of 2 का power है. That's all. So tell me the next one for the total 0 address instructions possible is equals to opcodes left into 2 power address bits or address size बोल सकते हैं, address bits. It means now this many opcodes are there whichever the number is there. So 0 address means this field also should be appended to the opcode field. Is it clear? So therefore now this is simply how many opcodes are left here for 0 address? How many are there? 216. So 216 into 2 power 4 minus 100 into how many? 2 power 4 bits, because the address bit field for the second address is 4 bits. So you find out, that is the answer. So just find out what is the value. If you have a calculator you can just find out what is the answer here. So 216 into 16, that will get as you can just check what is the answer. 3456. This is 3456 minus 100 into 16. That is the total number. So 3456 minus 100 sorry, minus 100, no, yeah, minus 100, you'll get value 3356, that is common, into 16. You just find out what is the value. So this value multiplied by 16, you'll get 53696. So these many zero address instructions are possible. Got it, everyone? Yeah. So you just check out whether the answer is correct or not. Yeah, very good, very good. Yeah, some people have solved it. Very good, Ishita. Yeah, good, good. Yeah, I hope you are able to understand, everyone. Clear? Right, next. All of you understood? Clear? Right. I hope you are able to follow the question. Clear, everyone? Right. Now we shall discuss about the performance of CPU, how to find out. I will just take one simple question which may include 2-3 concepts here, then we will be going to the next one, that is Amdahl's law and the pipelining concept. Because programming questions will be many questions, so I am mixing 2-3 concepts in a single question so that you can effectively understand the question, so that instead of discussing number of questions in hurry-burry, so we can discuss with basic concepts and clarity, with clarity. Okay, that is my intention. Okay, fine. So now we shall go for the performance of CPU. Okay, so how to find out the performance of CPU? Sorry, 1 minute. Performance. Fine. Performance of CPU. So performance of CPU is actually given by the 1 minute. Performance. Sorry. The performance of CPU is actually given by execution time. So performance of CPU is given by execution time of CPU for some program. Got it? Yeah. So now let us take one simple question. So normal basic level of question is like they will ask you some programs, some set of instructions. Each instruction takes so many number of clocks, clock frequency is given, and find out the total execution time. That is a simple question. Okay, so this is the total execution time formula. So total execution time is equals to 1 by clock frequency into number of clocks into count value. So count value means number of times an instruction or set of instructions, an instruction or set of instructions executed, an instruction or set of instructions executed, set of instructions executed, set of instructions executed. Clear? Right. So now this is the basic formula, but if different, it's a basic formula. For example, say you have silly questions like this, like they will give you total number of clocks, they will give you how many times the program is executing and what is the operating frequency. Substitute, you will get the answer. But sometimes the total execution time, the same thing can also be given in another way. So the same, the total execution time, I am writing in a shortcut. Okay, so total execution time, or in other words we can say the CPU time, both are same. Okay, CPU time is also given by sum of different instructions repetition, like different instructions. ICI means in a program different instructions are possible. Ith instruction count, how many times it is executing, okay, into how many number of cycles per instruction for that particular instruction, divided by total instruction count, how many instructions are there for that particular program, total instruction count. Okay, so this is what I am calling it as IC. Okay, fine. Sometimes the formula can be like this. Okay, and similarly the same question can also be given like percentage of execution of instructions. So I is equals to ICI by IC, this is called as percentage of occurrence of the instruction into CPII. Okay, so like this also you can find out. So you can call as this is total execution time. Okay, so it is cycles, you can find out for total average cycles. So here I am just giving you average cycles per instruction. Okay, average total execution time can be multiplied with number of cycle time, that is fine. So here I can write like this. So average execution, average cycles per instruction you have to find out like this. Okay, then you can find out the total time by multiplying by cycle time. Cycle time is simply 1 by f. So this is cycle time. So cycle time is equals to 1 by operating frequency, whatever is the operating frequency. So from this you will get number of cycles. If you multiply with that, you will get the total execution time. Like this you can find out. Okay, right. So sometimes the average CPI, average cycles per instruction, can also be given in this way. So they may give you like this. So this is called as percentage of occurrence. Okay, percentage of occurrence. Okay, of ith instruction, okay, like this also it is possible. So this is cycles per instruction for the ith instruction. So what is that? We shall take one simple question and solve it. Okay, understood? So let us solve the question. Just give me 1 second. Okay, fine. Right, let us take one simple question now. Okay. Question. From the following data, find a total execution time of program MIPS rate. MIPS means million instructions per second. Okay, next the other one is yeah, so we can find out your total execution time of program MIPS, this one, these two you can find out. Okay, or instead of that you can also write average cycles per instruction. Okay, average CPI means cycles per instruction. So this is the given. Okay, this is the instruction type. Okay, this one is ICI, this one is CPI. Okay, this is the given information to you. Okay, so load and store are 300 instructions and each instruction requires some 12 cycles to execute, and here the information is given to you. Clock frequency is given as 2 gigahertz. Okay, fine. Next, load and store. Similarly, arithmetic instructions are say some 200 instructions, logical are some 150 instructions, and shift and rotate instructions are some, let us say another 150, let us assume, and branch instructions are some 200. So total, if you take total instructions, how many are there? If you take total 500 plus 500, 1000 instructions are there. Okay, fine. And here the cycles which are required are 10. These require some 8. Shift and rotate also, let us say some 8, and branching may require some 4 cycles, like this. Okay, this is given. Fine. So from this you have to find out the given information. This any question can be given. So I have given average CPI, but first to find out this one you have to calculate the average cycles per instruction. So these are different, अलग-अलग instructions आपको दिया हुआ है. So sigma लेना, सभी का sum लेना, बस IC formula को use करो, find out करो. Very simple. Find out what is the answer. कैसे करते हैं? How do you solve? So simple. What is total execution time? Solution. पहले इसको find out करते हैं, ठीक है? Right. So solution. Very easy. First of all, find average CP. Average cycles per instruction. Average cycles per instruction is equals to sigma of I is equals to 1 to n ICI. मतलब पूरा ऐड करना है. That is the formula, right? Fine. हाँ, सभी ऐड करो. कितना है? ICI into CP. Formula मालूम है ना? This is the formula. Different instructions are there and every instruction is having some cycles. So पूरा sum करो, divide by total instruction count. That's it. Find it करो. Very easy. So tell me what is answer? 300 into 12 plus how much? 200 into 10 plus 150 into 8 plus another 150 into 8 plus 200 into 4, that is ICI into CPI, okay na? By total instruction count. How many? 300 plus this is fine, 1000 instructions. Find out this value. How much it is? How much you get? Just find out everyone. So solve it quickly. Very easy. Find out कीजिए. How much? This is 3600, no? Okay. So if I write here, what is the answer? So if I write here, it's very simple. So this is 3600 plus 2000 plus how much it is? 400, no? Sorry, 300, 1200, no? 1200. Okay, fine. Yeah, 1200 plus another 1200 plus 800. Total, this is 3600, right? Total divided by 1000. Find out कीजिए कितना आएगा. How many cycles you'll get? Average cycles per instruction. So 3600, 5600. 5600 means 6800. 6800, that is 8800. 8800 by 1000. Am I correct? Just check it once, all of you. So that is 8.8 cycles. Accepted, all of you? 8.8 cycles. Understood? Yeah. From that you find out the A question, part A. Yeah, quickly solve the answer. What is the answer? Yeah, shall we? So first one you got average CPI, you got it, average cycles per instruction, that you got. For example, average execution time per instruction also you can find out. So average execution time per instruction is equals to 8.8 into what is one cycle time? 1 by frequency, 1 by 2 into 10 power 9, that is 2 gigahertz is given to you. So how much it is? 4.4 nanoseconds, that is average execution time per one instruction. So you have to find out for total number of instructions. So that is first one you got here. So from that you find out part A. So part A you find out. What is part A? So part A you find out. What is part A? Very simple. So this is option, so this one is part C we found. Then for finding part A you had to find out this one. Did you understand? So till it is part 1. So for finding part A, first of all you should know average execution time per one instruction. So for total program, how many are there total? 1000 instructions. So total program, for total program how much it is? For total program, that is 1000 into how many, what is the time per one instruction? 4.4 nanoseconds. So that is simply 4.4 microseconds. Is it understood? Yeah. I think the data is correct only, no, everyone? Yeah, correct, 8.8. So what is the answer now? 4.4 microseconds is total execution time for total program. What is the total time? 4.4 microseconds. What is MIPS rate? So MIPS stands for million instructions per second. So very simple. Tell me, for see average for one instruction this much of time it is taking. Okay, for 1 second how many instructions are there? That is instruction rate, execution rate we say. So part B sorry, see part B, MIPS means million instructions per second, million instructions per second. So MIPS rate, how would you find out? Very simple. MIPS rate is simply given by F by CPI, frequency by CPI also you can do, okay, or you can say like this, very easy. For one instruction, how much time it is taking? 4.4 nanoseconds. So for 1 second, how many instructions are required? That's all, very simple. See, for one instruction this much time, for 1 second how many instructions? Reverse of it. That's all. You find out what is the value, how much it is. So MIPS means million instructions per second you have to find out. So how to find out? Let us take like this. So 1 by 4.4 into 10 power minus 9, okay. So if you write like this, so 1 into 10 power 9 by 4.4, you find out what is the value, convert in the form of millions, you will get the answer. Bataiye kitna aayega, how much it is? 1 divided by 4.4, how much you got? Okay, so you find out that value, how much it is? 1 minute. You calculate all of you. One by 4.4, how much? 0.227272, okay. So you will get 227272, right, into 10 power 9. But he is asking in terms of what? He is asking in terms of millions. Million is 10 power 6 you have to convert. So that is equals to, if you convert in terms of 10 power 6, it will be 227.27 into 10 power 6. That is what we are calling it as 227.27 MIPS. Okay, 5 million instructions per second. Like this you can understand. I hope you are able to follow everyone. Clear? Yeah, very good, correct. Yeah, so a few people are solving, you got correct answers, good. Clear, all of you, done? Yeah, correct, 227.27 million right, correct, very good. Yeah, nice. Next one. Let us go with the next one, that is the Amdahl's law and pipelining we will discuss, because the ALU data path, so there are different questions in that. I hope you understood this question, everyone, right? Fine. So now let us go for the next one. Right, what is this Amdahl's law? See, Amdahl's law states that when some portion of a computer is improved, what is the overall performance improved in the system? For example, say there is one old laptop, so you don't want to throw it off. I want to improve by updating the cache memory. So therefore, by improving the cache memory, or I am reducing that normal hard disk, I am putting SSD into that. Okay, so instead of normal hard disk I am putting SSD into that. Is it clear? So speed will improve or not? So some X amount of speed will be produced by improving that fraction of part of the computer. So by improving that fraction of part, like by updating that SSD instead of hard disk, what is the total system response? That is given by the Amdahl's law. So Amdahl's law states that, for example, say if some portion of computer is improved, what is the overall speed up that is produced? Speed up means the ratio of old time by new time. That is called a speed up. Okay, so let us see how to understand this one. Okay, so Amdahl's law, how it is given. So overall, S overall means S overall speed up. This is called as overall speed up. So speed up means it is telling how much enhancement is there, how much performance of system is improved. Okay, S overall is equals to 1 by 1 minus F means fraction of part improved of that system, plus F by S. S means the speed up of that particular fraction. Okay, right. So this is the formula, or you can also say 1 minus F plus f by s whole inverse ऐसे बोल सकते हैं. Okay, right. So s means f means fraction enhanced and s is speed up due to fraction enhanced. Got it? Yeah. So that is the formula. So let us take one simple question now. A computer has floating point unit and integer unit. If FPU means this floating point unit, okay, I am just naming this entire thing as FPU, okay. If floating point unit is used, if floating point unit is improved such that s is equals to 4, means speed up has improved 4 times, okay, for that particular floating point unit as compared to older one. So is improved such that s is equals to 4, means speed up is equal to 4, and if FPU is used for 80% of time, what is S overall? What is the overall speed up? That is the question. Okay, fine. So simply f is given, s is given, find out inverse. That's all. Very simple. What is the answer you get here? Very easy. What is the answer? This is the question, right? So solution. What is the answer here? So S overall. So what is S overall? Very simple. What is fraction enhanced? F is equals to 80%. 80% means we can write it as 0.8. And what is the speed up due to that improvement of 80 floating point unit? That is 4. So simply 1 minus f. 1 minus f means 1 minus 0.8 plus 0.8 by 4 whole inverse. So what is the answer? 0.2 plus this is how much? 0.2. So 0.2 whole inverse, that is simply 0.4 whole inverse, that is 1 by 4. Sorry, how much is the value? 4 by 10. Is it understood? Yeah. 4 by 10 means, so what is 1 by 0.4? How much? So it will be 2.5, right? So very simple, it is 4 by 10 whole inverse means it is 10 by 4. So 10 by 4 will result how much? 2.5 is the overall speed up of that particular computer. So like this we will have some questions on the Amdahl's law. Is it understood everyone? Right. Yeah. Next one we will discuss about the pipelining question. One question is there, we shall discuss about that. I hope you are able to follow. Yes, good. 2.5, good. Yeah, Shah Harsh correct, Ishita correct. Your answers are correct, good. Yeah, next one. Okay. So let me just tell you one question based on this. Okay. Okay, right. So we shall discuss one question on the pipeline. This is a question based on the pipelining. So what is pipelining? Pipelining is simply overlapped execution of instructions. By which average execution time per instruction will be reduced. Okay. So let us see how to understand this simple question. So these are the different states. You consider the following 4 stage instructions. So K is equals to how much? 4. K is equal to 4. 4 stages are there in that particular pipeline CPU, and different instructions are present in different stages. Like for example, let us take simply like this one. This instruction is present at for stage 1. Let us say 4 stages are there. S1 is equals to fetch stage, S2 is equals to decode stage, S3 is equal to execute stage, and S4 is equals to some S4 is equal to some, let us say, memory access stage, okay, or some write back stage, whatever it is, okay. Let me take as memory access, some write back stage, okay. Like this, some 4 stages are there: write back stage, execute stage, decode stage, and this is execute stage, this is decode stage, and this one is a fetch stage, and this is called what? Write back stage, means just to store the result, something like that. Like this, 4 stages are there. So first one is spending for 1 clock, this is for spending 2 clocks, and 1, and this one is spending 3, say 1, some 3 and 1, this is spending some 2, 3, 1, 2, and this is spending some 2, 1, 1, 2, something like this, okay. So these are the different time slots where the instructions are spending. So from this there are 2 questions. What is the speed up factor? What is speed up? Means if you take a non-pipeline CPU, for each instruction how much it is taking, so these are stages, and each instruction is spending this much amount of time. What is the clock frequency given here? Some value, whatever is the speed up given to you, let us say. So how many cycles are required here for these are simply time slots, okay. 1, 2 plus 3, how many? 6 clocks, 6 cycles are required for execution first instruction. Second instruction, how much time? 4 plus 4, 8 cycles are required. Third one, how much time? 5 plus 3, 8 cycles are required. Last instruction, 3 plus 3, 6 cycles are required. So for a non-pipeline CPU, unless one instruction, एक instruction पूरा execute करने से ही अगला में जाएगा, but pipeline में overlapped execution होता है. So total कितना हुआ बताइए यहाँ पर? 14 plus 14, how much? 28 cycles you got. 28 cycles. One cycle means 1 by f. 28 cycles. So for speed up, to find out, speed up is equals to speed up S is equals to time for non-pipeline CPU by time for pipeline CPU. Okay, right. So let us see for non-pipeline. So tell me, non-pipeline का total time कितना चल रहा है? 28 cycles. So this is 28 cycles by how many cycles for the pipeline CPU you have to find out. So for that we have to draw the diagram, okay. So space diagram you have to draw. So how to draw that particular space state diagram, space state diagram, okay. Okay. Okay, state space diagram, okay. So how many clocks it is spending, I have to find out, okay, right. So these are the clocks, okay. First clock, second clock, third clock, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, something like this, okay, fine. So I am giving you some time slots, say 1, 2, 3, 4, 5. Okay, something like this. These are the clock cycles, right? These are clock cycles. Clock cycles, right? So very simple. Here each instruction can use a particular stage only in that one clock period. मतलब एक stage में एक ही instruction उस stage को use कर सकता है. So what is overlapped execution? The problem is sometimes whenever each instruction is using a particular stage, उस time में दूसरा instruction before stage में रहना चाहिए. Okay, so in a particular time slot, in a particular clock cycle, each stage can be used by only one instruction. That is the point to understand. So very simple, क्या क्या stage लिया? Fetch stage, decode stage, execute and write back stage. Okay, 4 stages हमने लिया है. So tell me now for each instruction, let us see. First instruction, हाँ बताओ, very simple. Instruction 1 बताओ. Stage 1 में first stage में कितना clocks है? 1 clock. So it has entered the pipeline in the first clock. So this is first stage में है. Next, how many cycles for the second stage? 2 cycles. These are cycles, right? So decode stage, decode, 2 cycles. Next one, execution stage, 2 cycles. So execute, 2 cycles. Last one, write back stage, 1 cycle. Write back stage, 1 cycle. So this is the first instruction. इतना time लगा. लेकिन ये overlapped execution है, मतलब second instruction कब अंदर आएगा? Unless first instruction uses completes that stage, it cannot enter. मतलब fetch stage यहाँ पर आएगा. अब बताओ ये कौन सा कितना clocks fetch stage है? 3 clocks में है. Let us assume. So 3 clocks fetch stage में. देखो, this is already decode stage. It has gone to decode stage. So fetch stage is free. So 3 clocks fetch stage में है सच. Let us say, okay, right. So 3 clocks fetch stage है. Next one, 1 clock for execute stage. Sorry, decode stage. 1 clock for decode stage. Next one is 3 clocks for execute stage. Execute, execute 3 clocks and 1 clock for the write back stage, 1 clock for the write back stage. Next third instruction is again entering. अब बताओ, see already fetch stage busy है, so when does it enter into the this one, this clock, so यहाँ पर enter करेगा, there is fetch stage, okay, so fetch stage, fetch, next one is what, see decode stage यहाँ पर free है, so no problem, decode how many cycles, 3, 1 2 3, and next one is execute stage for 1 clock, execute stage for 1 clock, and last one is write back stage for 2 clocks. Are you able to understand? So if you observe here, the decode fetch, execute fetch, here execute decode fetch, write back execute decode, like this, so nothing is clashing here, okay, like this you have to follow. Last instruction देखो, instruction 4 कहाँ चल रहा है, instruction 4 यहाँ देखिए कितना है, so here it is, sorry I think I made a mistake, 1 minute, ये 2 है ना, I forgot that, 1 minute, a silly mistake, 1 minute. So here fetch is 2 states, right? So previous one was 3 1 3 1 3 1 3 1, that is fine. Here 2 3 1 2 2 2 3 2 3 1 2, accepted, no? Right, fine. Last one instruction 4, let us see how it is done. So instruction 4 will enter into the pipeline only in this particular cycle. So instruction 2 entered here, instruction 3 entered here, and instruction 4 has entered here. Ab dekho, so fetch how many states, 2, so 1 2, but observe carefully now, here the decode stage is already busy by the previous instruction, but it has to come into the decode stage now, so therefore the instruction 4 will be delayed in the fetch stage only, ये blank नहीं है, fetch stage में ही है, that is what you should know. So decode stage यहीं पर free हुआ है, therefore now it will enter into the decode stage here, decode stage, done, that is one stage, one cycle decode stage. But here if you observe the next one, what is the next one, execute stage, so execute stage free है, no problem, execute 1 and write back, but observe here already write back stage is busy by the previous instruction, so it must be delayed, so it must be delayed in the execute stage only, then once it is free then only it goes to the write back stage. So 2, did you understand, 2 1 1 2 2, okay, but because of this one extra delay, 1, this is next one is what, 1, okay, but because of this one it has been delayed. So total how many cycles are required, 14 cycles are required, got it. You check it once again, 1 2 2 1, next one is 3 3, okay, 1 3 1, next one is 2 and this is 3 3, and this is 1 and 2, that is correct, okay. Last one is 2 2, but decode stage is busy, so delayed, so 1, here it is 1 and the last one is 2 because delayed, and 2, 14 cycles, so it is 14 cycles. You just find out, so what is the speed of how much, 14 ones, 14 is 2, 2 is the speed of factor, yes, is it understood? So answer is 2 for part A, part A is answer 2. What is the second one, what could be the efficiency that is obtained by pipeline? Efficiency, what is efficiency? Efficiency means simply efficiency is calculated by second part B में efficiency, percentage efficiency is equals to simply S by K. K is number of stages, S is 2, stages are 4, that is how much, so this is into 100, okay, this is into 100 percentage efficiency, so how much it is, half means 50%, so that is 50% efficiency, efficiency is 50%, okay, right. So like this you will get the questions in the pipelining concept. All of you understood, clear? Yeah. So here the point to note is that in a particular clock cycle no two instructions can be present in the same stage, usko aapko dekhna padega. Is it understood? That is more important point, right? Fine. So like this we can understand different type of questions, okay. So these are the important topics you need to follow for the exam. Done everyone, clear? Fine. I hope everyone has understood this point. Okay, so the point to note here is, the point to note, I hope everyone has understood this, clear? So the point to note here is, no two instructions can be present in same stage in a particular clock cycle. Understood everyone, clear? Right. So that is the meaning of overlapped execution. So for a non-pipeline CPU, एक instruction पूरा खत्म होने तक it cannot go for the next instruction. But pipeline में this is called as overlapped execution. But did you understand why it got delayed here? This one, because decode stage was busy here, so it has to be delayed in the fetch stage. Here execute stage was decode is completed, so after that write back stage was here what do you call, the write back stage was busy, so it is still present in execute stage even though वहाँ पर एक ही clock cycle. Like this you will get different type of questions. Okay, so ये थोड़ा lengthy question है but easy to solve. Fine, right? So like this you can understand percentage efficiency is 50%, so 1/2 50. Right. Next one. You can copy it later on, okay, fine, because of time factor I am going little bit quickly, okay, fine. Next one we will discuss one more question. Yeah, another question on pipeline. Okay. So one question I will discuss on the control unit also, don't worry. These are very simple questions, just आपको 2 power n मालूम होना चाहिए, just coding, encoding you should know, you can solve most of the questions. Right, now observe carefully. So here there are 2 types of pipeline, observe carefully here, one simple question. Okay, right. So observe here, what is the question? The question is, there are 2 designs of pipelines for a synchronous processor, D1, D2. If there are 5 stages in the pipeline and D1 has delays of stage, means in D1 design there are 2 designs, D1, D2. Design 1 is having 5 stages, but look at this, all stages are different. For example, say 1, 2, buffer register is not given, so let us not worry about the buffer register. 5, okay. So these are the different stages, pipes we can say, okay, different stages. Right, so it's very simple. So this is the input of the pipeline, this is the output of the pipeline. So output of pipe, and this one is input of pipeline, input of pipeline, input of pipeline, okay, pipe or pipeline, okay, whatever it is. Okay, right. So this is stage 1, stage 2, stage 3, stage 4 and stage 5. 5 stages are there. So very simple. What are the delays of stages given to us? Very simple. क्या delays दिया है? 2, 3, 4, 5, 6. So 2 nanoseconds. Okay, let me write like this. So 2 nanoseconds, 3 nanoseconds. Other one is how much? 4 nanoseconds, 5 nanoseconds. Other one is 6 nanoseconds. Like this, there are it's not uniform delay pipeline, every stage is having different delays. So what we call it as non-uniform delay pipeline. बीच में buffer register होता है, all of them are operated by same clock only. In between there is a buffer stage, but I am not drawing here because in the question it's not given, right? So this is the clock which is operating parallelly all the stages, right? So this pipeline is a non-uniform delay pipeline. So non-uniform delay pipeline. So for non-uniform delay pipeline, so you must take T average. So what is the process cycle time? So TP. So TP, process cycle time, minimum time means maximum value of delays. Okay, whatever the delays are there, that should be the minimum value of time period for process cycle, TP, process cycle. So therefore, what is the maximum here? 2 nanoseconds, 3 nanoseconds, 4 nanoseconds, 4 nanoseconds, other one is 5 nanoseconds and 6 nanoseconds. So what is the maximum of this? So maximum of this will be how much? So what is the maximum of this value? you must take. So 6 nanoseconds is minimum processor cycle time. So TP, or you can say pipeline time, this minimum how much? 6 nanoseconds is required. Okay, fine. So here total number of instructions, how many are required? Total instructions means total n is equal to total how many instructions? 100 instructions must be executed, है ना? Right. So very simple, एक pipeline है, ठीक है? So इसमें मिनिमम प्रोसेस साइकिल टाइम मैंने एक क्लॉक साइकिल का टाइम कितना होना चाहिए मिनिमम? इट शुड बी 6 नैनोसेकंड्स. अगर ये नहीं रहने से देयर विल बी अ क्लैश इन द पाइपलाइन. दैट इज व्हाई मिनिमम साइकिल टाइम ऑफ द प्रोसेसर पाइपलाइन प्रोसेसर विल बी 6 नैनोसेकंड. हाईएस्ट वैल्यू जो है उसको लेना चाहिए, राइट? सो नाउ व्हाट इज अ D1 टोटल टाइम? सो D1 डिजाइन का टोटल एग्जीक्यूशन टाइम. सो फॉर्मूला क्या है? सो टेल मी, फर्स्ट इंस्ट्रक्शन तो ऑल स्टेजेस इट विल टेक. Okay, so that is minimum KTP will be taking first one. Okay, so first one will be how many stages are there? All the delays it has to pass. Remaining one will be in the overlapped execution. So therefore total execution time of the pipe 1 D1 का कितना आएगा? How much it is? He is saying which one? Yeah, so K plus N minus 1 into TP, that is equals to K, how many stages? 5 stages plus 100 minus 1 into 6 nanoseconds. You find out what is the answer. How much it is? 105 minus 1, 104 into 6 nanoseconds. 6 for the 24, 624 nanoseconds, right? 624 nanoseconds. That is for design 1. Now observe for design 2. So for design 2 we can understand here. So design 2, what is design 2? K is equal to how much now? K is equals to 8. What is TP value now? TP is equals to how much? TP pipeline time period. Here it is uniform delay. All the stages will have same time delay. So simply take 3 nanoseconds, and N is by the way same instructions. So find out what is the total time. So how much time is saved is asking. So total time of the design 2 will be K plus N minus 1 into TP. So therefore K means 8 minus 100 minus 1, K 8 plus 100 minus 1 into 3 nanoseconds. So how much it is? 108 minus 1, 107 into 3 nanoseconds. So that will give you 321 nanoseconds. So what is the time saved? Observe carefully, first one all are having non-uniform delays, so it is taking more amount of time. So it is taking only 321 nanoseconds. So what is the time saved? So time saved is equals to how much? 624 minus how much it is? 321 nanoseconds. So this is the value which is saved. So 303. So 303 nanoseconds are saved by using design 2, which has got uniform delay pipeline, because all the stages are taking the same delay. That is the answer. Okay, fine. Hope you are able to understand this question, right everyone? So two designs are there. First design total time, this is the formula. So TP is process cycle time, because you have to take maximum value here. Sometimes buffer time भी देगा, उसको भी ऐड करना पड़ेगा अगर buffer time देने से. यहाँ पर नहीं दिया है, we have taken only this one. Sometimes buffer register का time भी पूछेगा. Okay, so non-uniform pipeline. Got it everyone? Yeah. So like this you can solve the question. Everyone understood? Yeah, fine. Last question. I'll just take 5 minutes more. So we'll take one question from the this one what you call control unit. Okay, okay, I hope everyone got it right. So 1 minute. Right, last question we shall discuss from the control unit part. See, in control unit, data path ALU control unit can be designed by two types. One is the hardwired control unit, other one is the micro-programmed control unit. So this micro-programmed control unit will have two types. One is called as horizontal micro-programmed control unit, other one is vertical micro-programmed control unit. Is it understood? Vertical micro-programmed control. Horizontal, the only difference is that see this is the instruction format. So in the instruction format there are different fields. This one is the operation field of the micro instruction. So this is the micro instruction format, right? So you'll have the which one, the condition, branch condition, this is the flag condition, and this is the next micro instruction address, okay, fine. So here this is the micro instruction format. So what is horizontal vertical? In horizontal control unit, every control signal will have one bit. Means if there are some 4 signals, let us say 4 control signals are there, 4 bits are occupied. Means the length of operation field is horizontally increasing, right? So instruction length will be more. But vertical, the operation field, the control signals are encoded form. Horizontal, the control signals are decoded form. So how many control signals are there? That many bits are required in the operation field. But in the vertical type, how many control signals are there? They are present in the encoded form. So a decoder is required for that. Are you able to follow? So you may have certain type of questions here. So let us take one simple question here, right? So so only based on this one the 2 are differentiated, remaining story is same. So how many instructions are there? Based on that much control memory is also required. So for a computer having control microprogrammed control unit, 2 memories are required. One is control memory inside the CPU control unit, other one is the main memory outside the computer. Okay, so let us take one simple question, see how to solve this particular question. So total instructions are, let us say some 150 are there, 150 instructions, and each instruction requires 8 cycles. Let us assume 8 cycles are required, and let us say 120 control signals are there, and so it is following horizontal microprogrammed control unit. So now the question is, what is the it is following horizontal microprogram control unit. Okay, what is the minimum size of the control word and control address register? So he is asking what is the minimum size of the control word. Control word means this one. What is this control micro instruction control word? What is the minimum size of this control word? How many bits it is required? Micro instruction is simply the control word. Okay, so what is the control word size? How much? And the other one is what is the control address register? Very simple. As you got MER, memory address register, I say control address register. Okay, that's it. So he's asking what is the control address register? Control address register का value कितना होगा? So what is the length of these two is asking. So based on this you find out. So first of all you should know how much control memory is required for this. So very simple. पहले इसका फॉर्मेट का आपको हॉरिजॉन्टल मींस 1 कंट्रोल सिग्नल 1 बिट ईच. वेरी सिंपल. सो ऐसे फॉर्मेट में देखो क्या है. सो ही डिड नॉट गिव एनीथिंग अबाउट द ब्रांच एंड फ्लैग, सो अवॉइड दैट, डोंट वरी अबाउट दैट, राइट. सो फॉर्मेट कैसे होगा, लेट अस सी. सो दिस इज द फॉर्मेट, राइट, सिंपल. सो हियर दिस इज द ऑपरेशन फील्ड. So these fields are not given for us. So branch field and flag field are not given, and next micro instruction, how many bit address is required, you have to find out. So this is the micro instruction address. So very simple. So you have to find out what is this value and how many bits the address will come, that many bits the control address register value should be there, because control address register में ही होता है address of the control memory for the micro instructions. Got it? Right. Fine. So this is the operation field. So operation field कितना bit होना चाहिए? Very easy. Horizontal में how many signals are there? That many bits are required. Very simple. What is the value? 120 bits are required. So 120 bits are required. One signal, one bit for horizontal. अगर वो vertical होता तो encoded form में होगा. Right. So 120 bits. These two are not given. So leave it. Don't worry about them. And this is how many address bits are required. Tell me, one instruction requires 8 cycles. How many are there? 150. So 150 into 8 cycles will be the total micro instructions required. So one cycle means one micro instruction here, right? So how much it is? This is how many? 1200, no? Yeah, 1200 micro instructions. One cycle means micro instruction here. 1200 micro instructions. अब बताओ 1200 micro instructions के लिए how much control memory is required? Very simple. So 2 power n is equals to 1200. So n is equals to log of this one, you find out what is n is equals to log of base 2 आपको find out करना है. So इतना करने के बदले instead of that we can write like this. Okay, simple to calculate. कैसे करना है? So tell me, 2 power 10 is equal to how much? 1024. Followed? 2 power 10 is 1024. So 2 power 11 is how much? 2048. So 1200 is between these two, right? So tell me minimum number of address bits कितना चाहिए? 11 bits. Adequate. That's all. Therefore we can say n is equals to 11 bits. मतलब control memory में if 1200 micro instructions are there to address that control memory, so how many address bits are required? 11 bits are required. So this field becomes how many bits? 11 bits for the micro instruction, because micro instructions पूरा control memory में होता है within the CPU. So very simple. Now tell me what is the total length of this micro instruction. So this is 120 bits, this one is 11 bits. How much? 131 bits. So the first answer is control over 120 plus 11 is equals to 131 bits होगा first वाला question का answer. Second question का answer है what is the control address register? Same as MAR, control address register will hold the address of the control memory. So it is simply 11 bits. So these are the answers. So there is 131 bits, 131 bits, 31 bits, and this one is 11 bits. I hope you are able to understand this. Got it? Right. So like this you will get the questions in the control unit. Okay. Hardwired is fast. So if you compare the speeds of different control units, so highest speed will be hardwired. Okay, hardwired control unit will be highest speed, and the slowest one will be vertical micro programmed control unit. Beach वाला रहेगा horizontal micro programmed control unit, horizontal micro programmed control unit. So like this, इसका speed सबसे ज़्यादा speed ये रहेगा, and सबसे hardwired control unit is the highest speed one, and this is this one vertical, this is least speed in the terms of speed. अगर आपको compare करना है in the time of flexibility of adding the instruction, this is more flexible, this one is the least flexible. Like this you have got different type of questions. Are you able to follow everyone? Right. So these are different type of questions that can be given in the computer organization part. So I have given you certain type of questions. You can practice other questions. You can go through the Made Easy YouTube channel. There are some questions discussed there. Okay, so prepare well. So definitely you have to practice lot of questions. You'll get good scoring in this subject. Easy to answer the questions. ज़्यादा उतना worry होने का ज़रूरत नहीं, because it is initially introduced from 21 only. You can easily score the questions. Okay, so may God bless you. Prepare well, work hard. Okay, and go to the data. Okay, so this is how the questions can be posed to you in the kit. So these are some important topics. Addressing modes अच्छी तरह practice कीजिए. Programming, every instruction should be known, like shift and rotate, addition, subtraction, and or. Okay, go to that. So this is the total different type of questions, important questions which are in the CO for GATE. Okay, so all the best. Prepare well. May God bless you. Thank you so much for your valuable time.